Hello everyone, welcome to today's video. Today we'll be looking at the work solutions for the Selective High School Placement Test. We are looking at thinking skills. This is the most recently released paper, and so we'll be going through the work solutions for these. Hopefully you've had a chance to look at this before we go through the work solutions. If not, I highly recommend that you do that first before we go through the questions. And I also highly recommend that you have a physical copy of it so that you're able to work it out at the same time as I do. Alright, so without further ado, let's begin. Having a look at question 1 here, question 1 says, one piece of a puzzle is shown below. Which one of the following shows a view of the piece from above? So, if we have a look at this question, the answer to this question is B. Now, let's work out why the answer is B. Well, if we have a look, we're looking for the option that shows the top view of this shape here. And so what we're going to do is we're going to color code it a little just so you can see the different parts to it. And so you can see that there's one part that's here. So we'll just briefly shade it. So this is one part. And then there's another part here. And you can see it's directly connected. It leaves no gap between the blue and the blue, which was the largest outer section. And then you can see here that this part is also an L shape, but it's from here, from our point of view, it looks covered, but be warned that it is an L shape. And then finally we've got that last section there. And so you can see that it's all completely covered, all connected, because it's hitting the corners or the edges of that original shape. And so the only one that shows this with that correct L shape is B, where the first L shape is there, followed by the second one, which is down below. And then the one that was half covered is over here. And then finally, we've got that last little middle section there. So that's why our answer is B. Now, I'm going to also be telling you throughout these questions while we're doing this, how it's similar to the previous year's questions. And so this question is actually really similar in the 2021 paper to question 40, and these kinds of questions is the identifying similarity arrangement question. And so both questions are almost identical, asking for similar views of a 3D shape. The difference is that the 2021 question provides multiple angles, whereas the 2022 question is specifically about the top view. Alright, why don't we move on? Having a look at the next question, question 2. So question 2 says this. The train journey from Jasper to Salumba stops at 4 other stations along the way. Now, Jennifer boarded the train at Jasper and got off at the second last station. Cavalli station is located between Wadi and Gadapur. The train stops at Wadi before Anja. The train stops at Anja before Gadapur. Which station did Jennifer get off at? Okay, so with this kind of question, you can see that this question definitely requires a diagram so you can see what the train line looks like. Okay, and so I'm going to show you, and we're going to draw an example of a diagram. So first of all, maybe you've seen this in real life, but the way that they show a diagram for a train journey is through a line. And we know that it starts off at Jasper and it ends at Salumba. And it stops at 4 other stations. So that means that's 4 stops. So that's 1, 2, 3, 4. And we know that Jennifer gets off at this second last stop. So it's this stop here. Now, over here are 3 other clues. 3 other clues that we've got to follow to see which station did Jennifer actually get off at. So, we know that Cavalli station is located between Wadi and Gadapur. So, if we have a look, we don't know exactly where this is placed, so we're going to just write it on the side here. Cavalli station is between Wadi and Gadapur. Okay, so this is what we're going to write this up here before we put it into the actual diagram. And then what we also know is that the train stops at Wadi before Anja. So Wadi is before Anja. And we also know that the train stops at Anja before Gadapur. So Anja before Gadapur. Now what we've got to do is with all 3 pieces of information, we need to take these all in to be able to put them accurately within here. And so initially what we're thinking is when it says Cavalli, this first clue here, we're thinking, oh, it's got to be all right next to each other. However, we've got to add this extra station of Anja because it seems like it's also between Wadi and Gadapur. And so if we have a look here, we can actually we're going to put Wadi and Gadapur. And then we've got Anja and Cavalli. And with Anja and Cavalli, it could actually be in any of these 2 ones. But that's not really important. What's more important is knowing what our second last station is. So we can just actually plot Anja and Cavalli over here. Because technically these are interchangeable. We're not given enough information to know specifically which one is where. And so we know that the station that Jennifer did get off at is D, Gadapur. And so question 2, this question is a relevant selection verbal data processing question, and a very similar question to this in the 2021 past paper was question 2. Which was also relevant selections, but it was making conclusions. Both questions involved determining an order within the question by processing the clues given in the question, before selecting the correct position for one person or place in that order. Alright, so that's question 2. Let's move down to question 3. So question 3 says this. Question 3 has an information in the box, so with this similar structure, I'm sure it's quite familiar with you guys, but it's knowing and understanding what this means, then seeing how both of these 2 reasonings follow this above information. So let's have a go. It says, taller adults tend to have larger feet. So one more time, taller adults tend to have larger feet. So I think the key word here would be the word tend. But let's have a look at both of these 2 people's reasonings. So we've got Monaro, who says, your dad wears size 9 shoes and he's not as tall as my dad, so my dad's shoe size must be at least 10. Kevin says, no, that's not right. My dad's feet might be bigger than your dad's. If the information in the box is true, whose reasoning is correct? And we've got our options. So, what we're going to do first is we need to first understand this information like I said before, and we need to try and connect it to both of these. So, the key word that I want to highlight is this word tend. Now, what exactly does the word tend to mean? Well, if we have a look very carefully, the word tend means incline, be apt to, or regularly or frequently behave in a particular way. It's just essentially saying it's more likely, okay? So I'm going to write that down below. So if I had to explain this information up here, essentially we'd be saying taller adults it is more likely for taller adults to have larger feet. Okay, that's how we can rephrase this above information. Okay, and so if we have a look at what Manara says, your dad wears size 9 shoes and he's not as tall as my dad, so my dad's shoe size must be at least 10. Well, Manara's reasoning is actually incorrect. Why? Because once again, it says tends to, which is more likely. It's not guaranteed that his dad's shoe size would be larger than Kevin's dad's feet. Okay, and so Manara's reasoning is incorrect. Now, if we have a look at Kevin's reasoning, it says, no, that's not right. My dad's feet might be bigger than your dad's, and that is correct because he's saying might be, this word might be, which is telling us that there's a possibility that it may not be. It's a possibility that Kevin's dad's feet might be bigger than Manara's dad's feet, even though Manara's dad is taller. Because remember, taller adults are more likely to have larger feet. It's not always that outcome. And so that's why we know our answer to this question to be B, Kevin only. Now, question 3 is a detect reasoning errors making conclusions question. And a similar question to this to the 2021 paper is question 38, which is a detect reasoning errors, analogies and anecdotes question. Well, both questions involve a somewhat factual statement being given in the box above and then require students to make a conclusion based on this information. Students need to determine the arguments being made by the individuals and whether they align with the given information. So we know our answer to this question to be B. Alright, over the page. Having a look at question 4. So question 4 says this. Access to the meeting room for a secret club is only possible by answering 2 security questions. The questions are based on the following sentence. Only members will be allowed in. Now each day, everyone is given a number which is the starting position. When anyone arrives at the door, they are given 2 numbers and they have to say the letters that appear in those positions if counting starts at that day's starting position. Today, the first person was given the numbers 4 and 8 and responded with the letters E and O, which was correct. The second person was given the numbers 3 and 10. What letters should be given as the response? And we've got our 4 options down below. Now, this question is quite confusing because you might be wondering what do they mean by starting positions and what do they mean by the letters and how do they correspond to the numbers and things like that. So as you can see, one thing you need to understand is that the questions are based on the following sentence. So we're actually connecting that the numbers 4 and 8 responded with the letters E and O are related to the letters and numbers within here. Okay, that's the key thing. We are looking specifically at this. Okay, and so what we know so far is that the numbers, the first person was given the numbers 4 and 8, and the letters that corresponded was E and O. Now, we don't know what the starting position is, and what they mean by the starting position is looking here and seeing which letter is your starting position. And it's not always from the beginning here. And so we can see that it's respectively going from E to O. So E is first, followed by O. And you can see between 4 and 8, there's 5, 6, and 7. So we've got to have only 1, 2, 3, 4 gaps between our numbers. And so if we have a look at the above sentence, we're actually looking at the letters specifically to find that. And so we're going to try and find the gaps between O, E, and O. Now, O and E can't work because it's got to be E first. And then we've got E here, but nothing beyond until there. So let's find a closer E. And we do find a closer E between each other, E and O over here. So I'm just going to underline that. And so we're going to write this as number 4. And then we will see if the rest of work. 5, 6, 7, 8. Which works indeed. And so if we go back, we've got 3, 2, 1, we know our number 1 is that first L there. So we can see that 1, 2, 3. So if we look a bit more closer, 1, 2, so 1, this one's 1, 2, 3, 4, 5, 6, 7, 8. Now, what the question is actually asking us, once we've identified the grounds for this question, we're now looking at the main question here, which is the second person was given the numbers 3 and 10. So 3 and 10, what letters should be given as the response? So let's have a look. We know that number 3 is going to be this one here. And then 8, this is number 9 and number 10. So number 10 is an E as well. So if we have a look, our answer to the second person should be giving the code B and E to be able to be allowed in. So our answer to this question is C. So for this kind of question, it is an identifying similarity arrangement code question. And in actual fact, there is actually no question that is similar to this in the 2021 paper. And so although there are some code questions in the 2021 paper, none of them are really similar to this particular question. This is actually a really new type of code question, which might have been a bit of a challenge to some students who may have taken the test this year. Okay, so it's a matter of being really aware of the different types of questions and being exposed to them. So, yeah, trying them out and ensuring that you know the solutions to be able to work out these kinds of questions is quite important. All right, let's move on. Question 5. Question 5 says this: a bird sanctuary has 4 parrots, Cliff, Echo, Muse, and Sky. Staff at the sanctuary are keeping track of the treats the parrots like to eat. Now, they have found that if a parrot eats apples, it also eats carrots. If a parrot eats carrots, it also eats melons. No parrot that eats carrots also eats peas. Based on the information above, which one of the following must be true? So we're finding out a true statement within the following 4 statements. So we know that all 4 of these here are parrots, and we're just trying to find out what treats each parrot likes to eat and how they all relate. So we're going to draw a little diagram. There's actually 2 ways that we can draw a diagram. If you want to write it simply, you can write it as a Venn diagram, draw as a Venn diagram, or you can draw it as like a little flow chart just to see how it works. So I'll show you both ways. So what we know is that they have found if a parrot eats apples, so if a parrot eats apples, then it also eats carrots. So that means that's how we see it. And if you wanted to draw as a little flow chart, if you eat apples, then you eat carrots. And the key thing about using arrows is that it goes one way, but it doesn't necessarily go the other way. That's the key thing about using an arrow. Now, it says that if a parrot eats carrots, it also eats melons. So that comes in within. And if a parrot eats carrots, then it eats melons. And then it says, no parrot that eats carrots also eats peas. So technically, we don't know how it relates, but I'm going to just write down below in our flowchart that we can't see if it eats peas. And I'm going to just draw a circle here and write peas. And the reason why is because we don't see any other correlation. Just because it doesn't eat peas doesn't mean that it doesn't eat melons. Parrots might not eat melons just because they eat peas. So that's why we have this little section here. And what we'll do is we'll just color this section because it's not guaranteed. Okay? It's not guaranteed. And so that's why our diagram looks like this as follows. Alright, so let's have a look at our statements to see which one follows through and which one might not, which of the following statements must be true. So we've got A, if Cliff eats peas, he also eats carrots. Now, we already know that if you eat peas, no parrot that eats carrots also eats peas. And so, if you eat carrots, then you won't eat peas. And if you eat peas, there's no correlation to carrots as well. And so, we know that if a parrot eats apples, then it also eats carrots. So, that means that A is incorrect. We can't find that connection between peas and apples. Then we've got B. If Echo does not eat peas, he does not eat carrots. Well, that is incorrect because you actually either eat carrots or peas. Carrots or peas, okay? There's only two different charts to flow through. Then we've got C. If Muse eats peas, so if Muse eats peas, she does not eat apples. Well, that actually is correct because remember, like we said, if we have drawn this diagram because there's not enough information to tell us how peas is related to melons, but we do know that peas and carrots do not match together, and that means apples would not fit into that picture. And so that means that C is actually our correct answer. It is true, but just in case, let's go through D. If Sky does not eat apples, she does not eat carrots. Well, that's incorrect because that's incorrect. And so that means our answer that must be true is the answer C. If Muse eats peas, she does not eat apples. Alright, so for this question, to describe this question is a drawing conclusions, making conclusions questions. And a very similar question to this was in the 2021 paper was question 26, which is an identifying assumptions, multiple conclusions questions. And although the questions have different categories, they do share the same description, as both require students to make inferences and make a conclusion or conclusions based on a number of statements / clues that are all interconnected. So you can see that all the information here has some sort of a connection. That's why we're able to make a flowchart or even a Venn diagram just to see how it works. And so our answer to question 5 is C. Alright, let's move on to question 6. So question 6 says this. The principal of a school says PE classes should include non-competitive sports such as bushwalking and dance, and not just focus on competitive sports like football and tennis. Many students do not enjoy playing against their friends and classmates as it often leads to unhealthy rivalries. Now, which one of these statements, if true, most strengthens the principal's argument? Alright, so if we have a look here, this question we know immediately, if we look at the question, is a strengthening question. And so we've got this big statement here, and we've got to find out which one gives further evidence, relevant evidence, to really back up what the principal is trying to say. So the first step is to actually identify what's the main idea here. And so let's read it again. The principal of a school says PE classes should include non-competitive sports such as bushwalk and dance, and not just focus on competitive sports like football and tennis. So I think we've just identified our main idea, the main argument, which is classes should include non-competitive sports such as bushwalking and dance. Now, what we're going to do is we're going to identify the evidence that's being used here. And it says the evidence that the principal uses is that many students do not enjoy playing against their friends as it often leads to unhealthy rivalries. Now that here, I'm going to write down here, that's the evidence. So this here is the evidence. This here is our main idea. So the key thing is identifying the main idea and also seeing what kind of evidence has been given. And now we need to find which one strengthens that. And mind you, the word strengthening relates to the word supports, relates to the word agrees. So we're trying to find out which one of these options also agrees with this idea up here. And so we've got A, playing a competitive sports is a great way to learn the importance of teamwork. B, non-competitive sports are just as effective as competitive sports at improving fitness. C, PE classes are compulsory for students to attend. D, students like to have a range of different sports that they can choose to play. And so if we have a look at our options, the one that makes most sense, well, let's actually do a process of elimination. So, A, playing a competitive sports is a great way to learn the importance of teamwork. So, A is actually incorrect because it's actually going against what the principle is trying to say. So, this is actually a weakening argument because it's talking about the positives of playing a competitive sport. And so, A is incorrect. Then we've got B. Non-competitive sports are just as effective as competitive sports at improving fitness. Now, we know that this is a strengthening question, a strengthening statement, but just in case, I've got to look at the other ones because remember, we got to find one that most strengthens. C, PE classes are compulsory for students to attend. Now, this is a bit of an irrelevant statement. Yes, it's really focused on PE classes because the whole idea is PE classes, but it's not adding anything valuable to the main idea about including non-competitive sports. So we know our answer to question 6 is not C. Then we have a look at D, which says students like to have a range of different sports that they can choose to play. Well, yes, that is somewhat supporting and strengthening because we're including a wider range of sports such as non-competitive sports, but it's not the most strengthening one. And so out of our options, the best option that really strengthens this idea about why non-competitive sports should also be implemented is the answer B, because the ultimate point of having sports is to improve fitness. And so our answer to question 6 is B. And question 6, boys and girls, is an assessing the impact of additional evidence question, which is focusing on identifying strengths. Now, a very similar question to this was question 23 in the 2021 paper, where both questions give an opinion from a figure of power and then require students to determine their line of argument as well as choose how to best support the said argument. So our answer to question 6 is B. All right, having a look over to the next part, question 7. So question 7 is the following question. It says a street has a line of 5 houses next to each other on one side of the road. Now the 5 houses all have front doors that are painted a different color. A student looks at the houses from the opposite side of the road. The student labels them according to the color of the front door and records which houses are to be left and which houses are to the right of each house. Now, as you can see here, this table may be confusing, but I will explain to you how to read this table. Now it says which 2 houses are next to the yellow house. So from what we gather here, we know that there are 5 houses all lined up to each other. So 1, 2, 3, 4, 5. Now what we need to do is we need to identify the correct order of these houses, okay? And it's based on the color of the front door. Now, basically, what it means by houses to the left and houses to the right is that from, say, for example, the blue house, looking to the left, what other color houses are onto the left of that house? So if we have a look, you can see that it would definitely increase with nothing, then going with 1, 2, 3, and then 3, and then 4. So because as it's starting from the left, you'd have more going as you go down. And so we're going to focus on just the first column or the first row of information, because if we're going to look at it from the left, and so knowing your left direction, it's looking across from there. And so if we can see in the blue section, there's no houses that are next to the blue house from the left, and so that means the blue house is actually located over here. And then if we have a look, so we've just done this one. Now if we have a look here, the red house here, the red house only has to the left of it only one house, which is the blue house. So that tells us the red house is actually next to the blue house. And so we've just completed this one. And then looking at it, we've got two houses. So the next one with two houses next to, which is blue and red, indicates to us that the house in the center is the yellow house. And then following that same structure, we've got green, which has blue, red, and yellow. And then finally, we've got the pink house, which has blue, green, red, and yellow all to the left. Not in that specific order per se, but it's within there. All right, so we've just done that, and we can always use the bottom row of this table to check that we've correctly placed it. And this is from the right, so looking at it from this direction. And so we can see that pink has no other houses to its right, and then the green house has the pink house on its right. The yellow house has the pink and green house as shown here. The red house has the yellow, green, and pink house, which is going this way. And the blue house has the green, pink, red, and yellow houses on its right as well. So the question now is asking us which two houses are next to the yellow house. And we can see that the yellow house is here, which means that our answer is D, red and green, because they're both next to them. Alright, so our answer to question 7 is D. Now, this question, boys and girls, is a relevant selection data processing question, and there were no similar questions in 2021. However, 2022 question 7 is similar to the New South Wales sample question 12, in that both give many points of information from which students have to deduce and combine to arrange houses in order along a row. So 2022 question 7 also includes a table which has not been seen in previous questions written by students. And so it's quite, at first when you look at it, it's quite confusing, because you're like, what does it mean by houses to the left and houses to the right? But once you understand that, it becomes a lot easier, but it does require a lot of deducing to get to that point. Alright, let's have a look onto the next page. So question 8. Question 8 says this. Children at John's school were asked to complete a questionnaire about their sleeping habits to find out if they were getting enough sleep. Now, the survey found that people who read a lot at bedtime slept fewer hours on average per night than people who didn't. And then John says this. This shows that reading at night does not help you get to sleep. Now, which one of the following sentences shows the mistake that John has made? And so we've got our options to identify the mistake that John has made. Well, first of all, once again, we have to identify what this exactly is the main idea about. And the main idea here, if we have a look clearly, is that the survey found that people who read a lot at bedtime slept fewer average hours on average per night than people who didn't. So that's our main idea here. Okay, and so John says this shows that reading at night does not help you get to sleep. And so we need to find out which one of the following sentences shows the mistake that John has made. And on here, it's saying that people who read a lot at bedtime slept fewer hours per night on average than people who didn't. And John is saying that means that reading at night does not help you get to sleep. But this is actually incorrect, because this information here is not actually telling us why people who read at night didn't sleep as much than people who didn't. And John here is just assuming, oh, that means that reading doesn't help you get to sleep. But that might not be the actual case. So we've just identified the mistake that John has made. And his mistake is that he's assuming that reading at night does not help you get to sleep. But in here, it's not actually explaining us why people who read a lot at bedtime slept fewer hours. Okay, and so we need to find out which one is the mistake that John's made. So let's go through our answer options. A, it could be that people are reading more because they're having trouble sleeping. B, it could be that people who don't read as much spend more time playing computer games. C, it could be that some children are not allowed to stay up late reading books. And D, it could be that some books are more exciting to read than others. So this information here is actually telling us possible reasons as to why, which identifies the mistake that John has made. And so process of elimination. Well, we can definitely see that B doesn't make sense, because how can it be that people who don't read as much spend more time playing computer games? Then they would have mentioned it somewhere in this above information in the box. So B is incorrect. Then we've got C. It could be that some children are not allowed to stay up late reading books. Well, that doesn't actually tell us, doesn't really give us evidence as to why people who slept fewer hours slept less if they were reading. And so C is incorrect. And then we've got D. It could be that some books are more exciting to read than others. That may be the case, but that doesn't tell us exactly why people who read at night slept fewer hours, and that wasn't really what was researched here. And so therefore our answer is A. It could actually be that people who are reading more read more because they just can't fall asleep. And if we relate it to real life in this case, that is the case. And the key thing about thinking skills, boys and girls, is that you need to know there's a fine line between being able to connect things to real life, so using our background knowledge, and being able to just determine solely based on what's said in this question within. So you've got to be very careful about knowing when to apply it and when not to apply it. And so we know our answer to question 8 is A, and this was a detect reasoning errors identifying weakness question. Now, a very similar question to this was question 21 in the 2021 paper, where both questions involve determining a flaw, which was a mistake in a person's reasoning using the given information. So students have to identify the mistake in the individual statement. 2021 question 21 also includes some mathematical thinking, whereas this question didn't really. So our answer to question 8 is A. Alright, having a look over onto the next question, question 9. So question 9 says this. It says that each card in a set of 15 cards has one of 3 shapes on it: a triangle, a square, or a circle. Now, inside the shape, a number from 1 to 9 is written. No two cards are identical, which means exactly the same. Now, the only number that appears in both a square and a circle is 7. So which one of the following statements must be true? So just to give you guys a bit of a help you imagine this, we're imagining cards that look like this, but within them we'd either have a triangle, we'd either have a square, or we'd either have a circle. And within there we'd have numbers from 1 to 9. But we're not really given too much information other than this key point that the only number that appears in both a square and a circle is 7. So these are the only ones. 7 is the only one that appears in both of them. 7 and 7, and there's no other repeats in terms of numbers, okay? And we know that no two cards are identical. Now, this is going to be a lot of this is a bit of an assumption question, and this question is tricky because we're kind of playing this by ear, and it's kind of we're assuming to be able to get to our answer. So what we know is that we've got, we have 3 different shapes, so we're going to draw this into a bit of a table format. So we've got triangle, we've got a square, and we've got a circle. And so you can see here immediately the only thing that we know for sure is that there is a card that has 7 on a square and there is a card with a 7 on a circle, and that's it. Now, within here, from the other ones, we just need to add numbers from 1 to 9 and just play around with it essentially. And essentially, we need to also make sure that we don't include any more repeats of the numbers for the square and the circle like this. This would not work out. Only one of them can be 6, and if we wanted to repeat numbers, it would have to be between here and here, okay? But it's got to be just between the numbers 1 to 9. So if I wanted to, I could just go, okay, my triangles were 1, 2, 3, 4, 5, 6, and my squares could be 6, so I can repeat within here. 7's already written, 8, 9, because I can only go up to 9. So let's count. We need to make sure we have 15 cards. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And I should have a few more, let's say, circle cards. And because I can't repeat any of these numbers here, I'm going to repeat the numbers of these ones. So I'm going to add 11, 1, 2, 3, 4 if I wanted to. Now let's count if we have 15. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So we've got 15 cards, and this is what we're doing. Now just remember, blue is not set in stone, but we do know for one thing, we've only got 2 numbers here that are identical, and we can never have anything identical within here. Yes, we can have identical numbers within here like this, but nothing beyond finding any identical numbers between these 2 shapes. So which of the following statements are true? So we've just created a table, and we're going to now go through each of the options. So we've got A, each shape appears on 5 cards. Well, if we have a look here, we can definitely see that's not the case, because the triangle has definitely more than what the square and the circle have, and it's not indeed 5. So the answer is not A. And remember, it could be true, but we need to find something that must be true. So it's true every single time. Then we've got B. There are at least 5 cards with triangles on them. Well, that's true, because we've already got 6 cards in here, and we could have more. C. There are at least 5 cards with squares on them. Well, that could be the case, but in the example we've drawn here, remember there's many possibilities. That's not always going to be true, so it can't be C. Then we've got D. There are at least 5 cards with circles in them. Well, that can be true, but it's not always true. So remember, 1, A, C, and D are all can be possible, but or C and D can be possible, A is not possible. And so our answer, where it's true all the time, every single time, and must be true, is B. There are at least 5 cards with triangles on them. And boys and girls, the key thing to remember here is that this is not the only solution. Remember, there are many possibilities, okay? That's the key thing. There are many possibilities, and it's a matter of just seeing that these conditions are met, okay, to be able to work out your other possibilities, okay? And so that's one key thing you need to remember. Now, this question is a finding procedures verbal data processing question, and a very similar question to this in the 2021 paper was question 29, which was focusing on matching arguments, making conclusions. Now, both questions require students to work out which statement is true from a number of options using the given information. And so in 2021, question 29, not all of the given statements are true, so students have to determine which person is lying and which person is telling the truth. While in the 2022 paper, question 9, all of the information is factual, which students have to use to find the correct answer. So our answer to question 9 is B. Alright, having a look at the next part here, question 10. So question 10 says this. It says Hermione and her friends each had 3 shots at a target. Now it says here that Zoe scored 8, Bobby missed 1 and scored 4, and Gabby scored 11. Now all 4 zones of the target are worth a different whole number of points. The middle zone is worth the most points, and each zone is worth fewer points than the one inside it. So what did Hermione score? Now, what we need to do first is we actually need to identify, so we can see that this is a target, and we know that what's been determined is that from the middle, it's the most points because it's, and because it's the center, and then as you're moving out, the amount of points gets less and less, okay? And what we know is that Zoe scored an 8, Bobby missed 1 and scored 4, Gabby scored an 11, and we're going to try and determine what Hermione scored based on what's been here. Now we can see here that this has the most points, and then it slowly increases, or the numbers get less as it goes further beyond. And so if we have a look here, it's a matter of just trialing out different number combinations. And so if we have a look at Zoe's, we can see here that let's imagine the outside to be different combinations to get to 8 with 3 numbers could be 5 plus 3 plus 5 plus 2 plus 1. Okay, and so if we have a look, 5 plus 2 plus 1 gives us 8. And so we can assume that the middle section is 5. This could be 4, or this can't be 4, because we need to make sure that this part is 2. So this could be 3, and then 2, and then 1. And so we can see that Zoe scored a 5 in the center, so that's 5, a 2 which was not in the second ring but the third ring on the outside, so that's a 2 here, and then finally on the outer ring, which is a 1 there. So 5 plus 2 plus 1 is an 8, makes sense. And so let's check here. Once again, he hit both targets within the third circle, so that's 2 plus 2, which is 4, that works. And we try here. 5, Gabby scored the best, 5 and 3 and 3. Does that equal to 11? 5 plus 3 plus 3. Yes, indeed, that equals to 11. And so now we know what the score range of each of the rings are, we can work out what Hermione scored. So Hermione didn't get anything in the middle, but we know that she hit in the second ring, so that's 3 points. There's 2 points and there's 1 point. So 2 plus 3 plus 1 equals to 6. So what score did Hermione score? Our answer is A, 6. And so, boys and girls, this question is a finding procedures number concepts questions. A very similar question to this was in the 2021 paper was question 22, which was also a finding procedures number concepts questions, where both questions involve the use of mathematical operations and arithmetic to formulate an answer. Now, 2022 question 10 is more difficult as it requires students to figure out 3 missing values for the number of points scored in each area of the target. Alright, so that's question 10. Moving on to the next page, having a look at question 11. So question 11 says this. It says, Jake and Robert are brothers. Their parents have told them that they will not be allowed to go to the party tonight if they have not completed their homework. Now, Natalie says this. Jake is coming to the party, but Robert is not, so Robert can't have completed his homework. Daniel says, Jake must have completed his homework. If the information in the box is true, whose reasoning is correct? So once again, we are looking at this information here, and we're going to try and see how that relates, how Natalie and Daniel's reasoning is correct or incorrect based on this information. And so it's a matter of understanding this, okay? And so the key thing we know is that they will not be allowed to go to the party tonight if they have not completed their homework, okay? That's the key piece of information. Now, what we know is that Jake is coming to the party, but Robert is not. So Robert can't have completed his homework. And so if we have a look, basically, we know that Jake is coming to the party, but we're focusing on Robert here, and Robert's not. And Natalie is assuming that Robert can't have completed his homework, but he actually might have, but he's had other circumstances. What if he's got another assignment, or what if he is sick, we don't actually know. And so that's why Natalie's reasoning is actually incorrect, because she's immediately assuming that it's because Robert didn't finish his homework that he's not coming. But there might be an actual case where he actually doesn't want to go, and there's other circumstances as to why he doesn't want to go. And then we've got Daniel here who says Jake must have completed his homework, and that's correct because Jake is coming to the party from what Natalie is previously saying. And so, if the information in the box is true, whose reasoning is correct? Our answer is B, Daniel only. And question 11, boys and girls, is a detect reasoning errors question which focuses on analogies and anecdotes. And in the 2021 paper, question 11 was a very similar or question 9 was a very similar question, where in both questions the two individuals are referring to a third party, which is Jake and Robert, and students have to deduce whether each individual statement has correct reasoning. Okay, so that's question 11. Okay, so having a look at question 12 now. Question 12 says this: some sets of 3-letter words can be ordered so that no two consecutive words have any letters in common. And so we've got, for example here, we've got our we've got a set of words, 5 words, and they're all 3 letters each, and it's in an order of bog, cat, dog, met, and sup. Now it says another such set of words is given below, but one word is missing and they are not in the right order. We've got the words age, can, cot, and pad. Which one of the following could be the missing word from this set? So if you have a look here, it's a matter of understanding these rules here and how this works to be able to then work out our missing word from this set and the order these sets of words need to be. And so if we have a look here, we've got the words bog, cat, dog, met, and sup. And so if you have a look here, we've got let's understand how this works. So we've got all 5 of these words are 3 letters each, and you'll notice that consecutive, which means right next to each other, bog and cat don't have any repeating letters in between, so this works. And then if you have a look at the next one, cat and dog, none of them repeat, so that works as well. And then following that idea, we've got to go from dog to met. There is no repeating letters, so that works. And then finally, with met and sup, you can see that also none of them are repeating, so that works as well. And so following that same idea, we're given another set of words, and they're not, one word is missing because we've only got 4 here, and they're also not in the right order. And so we need to find out which one of the following could be the missing word from this set of 4 options, as well as and to be able to do that, we actually need to identify what order this needs to be in first as well. So we know that there are 5 words in a set, so we're going to just write 1, 2, 3, 4, and 5. And we can see here that we're going to look at each word and see what are the repeating letters within each one. And so as you can see, our repeating letters are A's. So we've got 3 words that have A in there, and we've got 2 words that have the letter C in there. And those are the only repeating letters within here. And so if we know that there are 3 letters in A, they're going to go into, I'm going to actually do this in blue. We know that these 3 words would be in the positions of 1, 3, and 5 within these 3 points, because they can't be next to each other because they cannot overlap. And to add on to this, we also know that cot and cannot be next to each other as well. And so let's start solving through this. So if we have a look here, we're going to put and to find out what the missing word is, it's a matter of just going through each word option to see how where it could possibly fit. Okay, and so what we're going to do is we're going to first actually start off with the word can, or even the word cot as well, because if you have a look, cot and can, they can't be next to each other, and cot is going to be in either one of these 2 positions. Okay, and so let's, for example, start placing cot on this position, that means can can't be here and can can't be here as well. So can can't be in the first position or the third position because C is within here. So that means that can has to be at the end. And so we've just done can and cot. We've still got pad and age. So we know that pad and age can't be next to each other, so it's going to be in one of these two positions, but we also need to fit in the word sud as well. Now, sud has to fit in here because that's the one that doesn't have an A in there. And if you have a look at that, that means we can't have C as our option as well. And so we can eliminate one of them straight away. And so if we put sud in our fourth position, so that means sud is done. Then we've got to fit in pad and age. Now pad can't be here because D would be repeating each other, so we put pad over here. And then we would fit our only remaining word, which is the word age. And that works because you'll see that none of these letters are repeating consecutively to each other. And so that means our answer option is A. But boys and girls, it's a matter of just trialing and erroring this out and putting them into the different combinations, but making sure that they adhere to this above rule here. And so our answer to question 12 is A. And so what we've noticed in this question is that it's an identifying similarity arrangements question, and this question is not similar to any question in 2021. It appears similar to a code question at first, however, it is more focused on word formation like in the old GA papers. So getting a bit more exposed to GA questions as well, if we have a look. Alright, so that's our answer to question 12. Alright, moving on to question 13. So question 13 says this: in Ocean Town, there are 5 different coins. We've got Azes, we've got Bayos, Cots, Dwits, and Anits. Now it says there are 4 Azes in 1 Bayo, 2 Bayos in 1 Cot, 2 Cot in 1 Dwits, and 4 Dwits in 1 Anit. How many Azes are in 1 Anit? Now, what we've got to do in this kind of question is we've got to actually work this out into number sentences, and a bit of algebra would be involved in this. So our main question that we're trying to look at is how many Azes are in 1 Anit. So that's our main question. So we're going to write that. 1 Anit is equal to how many Azes? And we're going to actually abbreviate all of these by just using the first letter of each word. Okay? So this is what we know. We know that 4 Azes are in 1 Bayo, and we know that 2 Bayos is equal to 1 Cot. And we also know that 2 Cots are in 1 Dwit, and 4 Dwits are in 1 Enit. And we want to find out how many Azes are in the Enit. So we're kind of trying to get from A, and we're going to try and make that connection from A all the way to the E. And how do they relate together? Okay, so how are we going to do this? So, excuse me, boys and girls. What we're going to do is we're going to slowly make our way from all the way to A and slowly find those connections from how A and C are related, and then how A and D are related, and then how A to E are related as well. So let's begin. So if we know that 4 Azes are is equal to 2B, we also know that 8 Azes is equal to 2 Bayos, which is equal to 1 Cot. Now, that also means that we know that 2 Cots is equal to 1D, so we also know that 16 Azes is equal to 4 Bayos, which is equal to 2 Cots, which is equal to 1 Dwit. And then we also know that, it's like repeating as we go, 64 Azes is equal to 16 Bayo, which is equal to 8 Cots, which is equal to 4 Dwits, which is also equal to 1 Enit. So how many as's are there in one unit? From this conclusion, we can see that 64 as's is equal to 1 unit. And so our answer to question 13 is C, 64. All right, and so, boys and girls, this kind of question is a finding procedure simple number operations, and a very similar question to this in the 2021 paper was question 28, where both questions involve counting the number of objects and unit conversion between different categories. Okay, whether that be animals and legs in 2021 or different types of coins in 2022. Okay, it's a matter of seeing how you'd work from here to here in a slow, steady process. Okay, ultimately it wasn't too hard once you see the connections between them. All right, let's have a look at question 14. So question 14 says this. Ying thinks we should all buy soybean oil instead of palm oil for cooking. I found that growing palm oil trees requires vast areas of rainforest to be cut down. Ying says to help save the rainforest and animals that live in them, we must stop buying palm oil. Now, which one of these statements, if true, most weakens Ying's argument? So then we've got A, B, C, and D to follow through here. And so what we need to do is we need to find out which one, it's a weakening strengthening question, which one most weakens. So essentially it's asking us which one disagrees with Ying's argument. And we can see that Ying's argument is focused on the main idea that we should all buy soybean oil instead of palm oil for cooking. And the reason why her evidence is that it's because growing palm oil trees requires vast areas of rainforest to be cut down. And so, to help save the rainforest and animals that live in them, we must stop buying palm oil. And so, that's her conclusion that she's made within here. All right, so now that we've done that, we need to find out which one disagrees with Ying's argument and takes a different perspective and says, no, there's also a problem with buying soybean oil. So let's go through our options. We've got A, palm oil is also used in bath products such as shampoo, with this question, with option A, we can see that it's not really weakening Ying's argument because it's just saying that palm oil is also used in bath products, and we can't really say that that helps to disagree with why we shouldn't use palm oil, because Ying could possibly just counteract to that and say we can use other products to rather than palm oil within our bath products. So that's why A is not really a weakening statement. Then we've got B. People are using less oil in cooking than they used to. Within here, this is also not quite a weakening statement because, yes, this may be the case, but it's not really going against why we shouldn't use soybean oil specifically. And so, B is not our answer option either. Then we've got C. Growing soybeans also involves the destruction of rainforest. Now that is a weakening statement because it's saying, okay, so the main reason why Ying is saying we shouldn't use palm oil is because it involves cutting down rainforest. But growing soybeans would also have to be the case. We would have to destroy rainforest to create land to be able to grow soybeans anyway as well. And so that's why C is our most weakening statement. But if we have a look at D just in case, it says palm oil is more frequently listed in recipes than soybean oil. That may be the case, but we could easily counteract that by saying we can use alternatives to different types of oils. And so that's why C is our best answer. And so if we have a look, question 13 is a finding procedures simple number operations questions where both questions involve counting the number of objects, or where, apologies boys and girls, question 14 is an assessing the impact of additional evidence question, identifying weakness question. And in the 2021 paper, a very similar question to this came out, where both questions require, and that question was question 5, and this question, both questions required students to determine the main point of an argument and figure out a statement that would most go against that argument, thereby weakening it. And so both questions have a similar field of topic. Alright, so that's question 14. Let's move through onto question 15. So question 15 says this. It says, the skills required for rollerblading, roller skating, and ice skating are very similar. Anyone who can rollerblade can also roller skate. Anyone who can rollerblade can also ice skate. Not everyone who can roller skate can rollerblade, and anyone who can ice skate can also rollerblade. Now, that's what the information in the box says, and then it says, and then we've got two people's opinions within here. We've got Wei, who says that Shane has been ice skating for years. He will have no trouble roller skating. Talia says Hannah is unable to rollerblade. She won't be able to roller skate. And so if the information in the box is true, whose reasoning is correct? So once again, we're trying to match Wei's and Talia's reasoning based on this box up above, okay? And so let's slowly read through each answer option and or let's slowly look and analyze each person's opinions and then see if they're correct or incorrect based on this information up above. Okay, so if we have a look here, we know that we need to first understand this information here. So we know that this rollerblading, roller skating, and ice skating are very similar. Now we've got all these points here. It says anyone who can rollerblade can also roller skate. So if you can rollerblade, you can also roller skate. Now anyone who can rollerblade can also ice skate as well. But it says not everyone who can roller skate can rollerblade. Okay? So basically, if we actually drew this into a Venn diagram, this is what we know. This is rollerblading, and anyone who can rollerblade can also roller skate. But it says anyone, not everyone who can roller skate can rollerblade. So that's why we've drawn this one to be a lot bigger than this one, okay? And then it says anyone who can ice skate can also rollerblade. Well, basically, this means that ice skating also overlaps within here. So this is is ice skating. And so this is the kind of diagram we've been given. Now Wei says this, Shane has been ice skating for years. He will have no trouble roller skating. Well, that is correct because this is within the roller skating category. And so we know that Wei's reasoning is correct. Now, if we have a look at Talia's reasoning, it says Hannah is unable to rollerblade. She won't be able to roller skate. So if she can't rollerblade, that means she can't even roller skate because anyone who can rollerblade can also roller skate. And so, if you have a look at this, her reasoning, she won't be able to roller skate, is incorrect because what if she can actually roller skate within here? Doesn't mean that she has to rollerblade, okay? Because look at it, there are categories where people can roller skate but not rollerblade, and there are cases where you can ice skate, but if you rollerblade, then you can roller skate, but it just doesn't go the other way. And so that means that Talia's reasoning is incorrect, but Wei's reasoning is correct. And so if the information in the box is true, whose reasoning is correct? Our answer is A, Wei only. Alright, so that's question 15. Let's move down to question 16. And before we continue, boys and girls, question 15 was a detect reasoning errors, analogies and anecdotes question, and a very similar question to the 2021 paper was question 27, where this question is not similar to any question in 2021. However, it requires similar skills to question 12 in the same paper. Okay, so in that, students have to identify a continuation of series in which there is no repetition across consecutive terms. So like I said, even though it's similar to question 27 in the 2021 paper, the actual if you have a look at it, it's because it's within the same categories of detect reasoning errors, analogies, and anecdotes, but they're very different situations in both of them. Okay, and so that's the differences between them. All right, let's have a look at question 16. So question 16 says this. The string of symbols below contains 4 symbols only. You can see that it includes a dollar and at and hashtag sign. So it says here hashtag dollar and hashtag and at hashtag dollar and at and so forth. Now it says, what is the only one of these 4 siblings that can be added on the right hand side of the string to ensure that there is no repetition or three consecutive symbols anywhere in the string? Okay, so we've got to make sure, we've got to choose which one can be added at the end for it to continue, like for there to be no repeats within. Okay, and so let's go through each option to see how this works. Okay, so imagine that we put a dollar sign over here, so that means our 3 consecutive is and at dollar. We need to see if that can actually work, if there's no and at dollar together. And so if we have a look here, the and at dollar, there is an actual and at dollar there. And so that's why it can't be the dollar sign. So it can't be A. And then let's have a look at the next one. So if we can't do the and at dollar, let's do the and at and. So we've got to find and at and. And so if we have a look, we've got and at, and at, but not and at and. We've got at and at, but we don't have and at and, so B could be our option. But let's have a look at the other one. So let's say if we had at, so we've got and at, and I can directly see that here, and at, so it can't be at. And then let's do our last option, which is the hashtag. So it's got to be and at hashtag. And so if we have a look, we've got and at hashtag over here. So that means the only one that's not repeated and hasn't been used, the pattern, is the answer option B with the and within. So our answer to question 16 is B. All right, let's have a look at question 17. So question 17 says this. And boys and girls, before I continue, question 16 was a identifying similarity arrangement question, and this question is actually not similar to any question in 2021. However, it requires similar skills to question 12 in the same paper, in that students have to identify a continuation of series in which there is no repetition across consecutive terms. So it was a very similar question to the series question that we did earlier beforehand. All right, so that's question 16. Let's move on to question 17 now. So question 17 says this. Sarah wants to persuade her cousin Rhiannon to come to the school play. Her only chance of persuading her is if Sarah's brother Sam is playing in the school band. The problem is it's very hard to get accepted into the band since the standard is very high. Now, even some very talented musicians have been turned away. You need to really impress the music teacher at audition to stand a chance. Sam does not practice hard enough to get to that kind of level. So if the above information is correct, which one of the following is not possible? So remember, the key thing is not possible. Now, the key thing the ultimate thing that wants to be happening here is that Sarah wants to persuade her cousin Rhiannon to come to the school play, okay? But there are some things that are hindering that, because the only chance of persuading her is Sarah's brother is playing in the school band. But it's very hard because one, you have to be the standard is very high, and Sam does not practice hard enough to get to that kind of level. So we need to have a look at our options and see which one of the scenarios here is not possible. So process of elimination, let's go. We've got A, Sam impresses the music teacher at audition but is not invited to join the band. Now that is definitely possible. Why? Because it says that even some very talented musicians have been turned away. So A is actually possible. Then we've got B, which says Sam practices hard but does not impress the music teacher at audition. Now that is actually possible as well, because even though he decides to practice hard to get in, his teacher might not be impressed. The music teacher might not be impressed, so that's possible. C. Sam does not impress the music teacher at audition, but Rhiannon still comes to the show. Now, we know that that's not possible because we know that Sarah's only chance of persuading Rhiannon to come is if Sarah's brother Sam is playing in the school band. And so C is not possible. But let's go through D just in case. Sam is accepted into the band, but Rhiannon does not come to the show. That may happen, but we're not 100% sure, boys and girls. So D is not guaranteed, and we know that Rhiannon will come to the play if Sam is actually playing in the school band, because we're trying to follow the logic that's within the question itself. And so that means the one that's not possible is that Rhiannon still comes to the show even though Sam does not impress the music teacher and hence doesn't play in the school band. And so our answer to question 17 is C. Now we know that question 17 is an identifying assumption question focusing on multiple conclusions. A very similar question to this was question 26, where both questions require students to analyze given information and assess various outcomes to find an outcome that is not possible according to the criteria. Alright, so that's question 17. Alright, let's have a look at question 18 now. So question 18 says this: scrub jays are a series of birds that will bury some of the nuts they collect in order to save some food for later. Now, scientists studying the species made an interesting discovery that, number one, some scrub jays move nuts they bury if they see other scrub jays watching them bury the nuts the first time. And number two, it is only those scrub jays who have previously stolen nuts from other scrub jays that move their nuts. Now Logan says this: that means that a scrub jay must be able to predict what other scrub jays will steal, which other scrub jays will steal its nuts. And Kimberly says if a scrub jay moves a nut it has buried, you can be sure it has had its nuts stolen before. Okay, so once again, what we've got to do is we've got to have a look at Logan and Kimberly's reasoning and see if they match the above reasoning information in the box, okay? So let's highlight the important pieces of information here. So scrub jays are a species of bird. So they're birds that will bury some of the nuts they collect in order to store food essentially. And what's more important, boys and girls, is these 2 points here. So it says that some scrub jays move nuts they bury if they see other scrub jays watching them bury the nuts the first time. Okay, now it is only and point number 2 was those scrub jays who have previously stolen nuts, so not getting experience of their nuts being stolen, but who have previously stolen nuts from other scrub jays that move their nuts. Okay, so it's a matter of really understanding this, because this is the confusing part. Okay, so some scrub jays move their nuts they bury if they see other scrub jays. So you got to kind of imagine yourself in that position. If you're trying to hide something and you see someone watching you hide that, you're going to assume that that person might steal your stuff, right? So you're going to move your stuff afterwards. So that's essentially what a scrub jay is doing. Now, this one you can also apply to yourself as well. Imagine that you've stolen stuff before and you know how people work. So then you're going to be moving. So if you've previously stolen and you're trying to hide something, you're going to also move your nuts as well, just to be sure and safe. And so that's what scrub jays do. Their behavior is also very that's the behavior that they're following. And so we're going to see if Logan and Kimberly understand that and follow that logic. So this is what we've got. It says that means that a scrub jay must be able to predict what other scrub jays will steal its nuts. Well, for this case, we know that Logan's reasoning is incorrect, okay? Because in actual fact, scrub jays aren't able to predict which other scrub jays will steal its nuts. Because what if the scrub jay that's watching them doesn't actually steal them? They're just watching them for the sake of it. We don't actually know for sure. So that's not a really guaranteed answer. And the key thing here was must. They may be able to predict, but we're not 100% sure of that. And so Logan's reasoning is incorrect. Now, Kimberly, if a scrub jay moves a nut it has buried, you can be sure it has had its nut stolen before. Well, Kimberly's reasoning is incorrect because a scrub jay moves its nuts for two different reasons. One, if another scrub jay watches them bury the nuts for the first time, or number two, if that scrub jay that's moving its nuts has previously stolen, not has had its nuts stolen before, it's previously stolen itself, other scrub jay's nuts. So Kimberly's reasoning is wrong as well. And so if the information in the box is true, whose reasoning is correct? Our answer to question 18 is D. Neither Logan nor Kimberly's reasoning is correct. And so our answer to question 18 is D. Now, both questions, boys and girls, is a identifying arguments, detect reasoning errors, identifying arguments question. And this question is very similar to question 6 of the 2021 paper. Where both questions require students to work out which statement is correct based on the given information in the box. Both questions also refer to the topic of animals and their behavior. So this can be quite confusing, but I think if you're familiar with the animal, it's a lot easier. But if you're not familiar with it, you have to really break it down to see how that works. And so our answer to question 18 is D. Alright, continuing on. So having a look at question 19 now. So question 19, let's have a look. It says, in a game called Splots, there are tokens that are worth 2 points, 5 points, or 10 points. And it says, I have one pile of 2-point tokens, one pile of 5-point tokens, and one pile of 10-point tokens. Now each pile contains the same number of tokens. The combined total of two piles of the tokens is 96 points. What is the total of the other pile of tokens? Alright, so what we've got to do here is we're going to draw a little table. We've got 2-point tokens, we've got 5-point tokens, and we have 10-point tokens. Now, what we know is that each pile of tokens actually has the same number, okay? And the total of two piles of tokens is 96 points. So looking at the point score, it's 96 points. And so what is the total of the other pile of tokens? So we're trying to find out the total of the other pile of tokens, the one that's left over. So what we've got to do is we've got to think of combinations that get to 96, but it's also got to have the same amount, okay? So thinking about it, we can kind of use algebra to work this out, okay? So thinking about it, we don't know the amount of tokens within there, but we know the point worth of each of these tokens, okay? And so we need to make sure that it just equals to 96, okay? So if we have a look, we can use a bit of trial and error, and 96 is quite a big number, and so you would assume that it could most possibly use 10 points as one of them, and we've got to have the same number of tokens for 10 with 2. And so if we have a look here, let's imagine it to have 8 tokens here, which is 80 points. And then we're going to imagine that there's 8 tokens here as well, which is 12 points as well. And so 80 plus 12 is equal to 90, which is 16 points. My apologies, boys and girls. So 8 times 2 16, so 8 plus 16 is 96. And so we've just been able to easily determine the nature of the number, how it's 96 points. And so we can see that it's quite a big number and a small number. Using our logic, we can actually see that we've got to use a big and small amount because they've got to still have the same amount of tokens to make up to 96 points. And so using a bit of our number knowledge, we can see that it's got to be 10 and 2. And so from there, we can now know that for the 5-point tokens, we have 8 tokens, and how much is those points worth? Well, 8 times 5 is equal to 40 points. And so our answer to question 19 is B, 40 points. And so number 19 is, this question, boys and girls, is a finding procedures mixed number operations question. And this question is not similar to any question in 2021. It involves mixed mathematical operations and algebra to work out an unknown value. And so there were no such questions in 2021. Alright, so that's question 19. Let's have a look at question 20 now. So question 20 says this: space exploration is a waste of time. When governments spend money on sending people into space, there is less to spend on helping people in need and on improving services for everyone. Scientists say that when they do experiments in space, they learn more about the universe, but their work would be more useful if it made life better here on Earth. And so, if we have a look, it says which one of these statements, if true, most weakens the above argument. So we know that this is a weakening question, and we need to find something that that goes against this, or essentially goes against the above information here. And so first of all, it's identifying the main idea, and the main idea is simply that space exploration is a waste of time. Remember, when you're trying to find the main idea, you want to get as simple as possible, okay? And so we've realized that the main idea here is just simply that. Now, if we have a look, when governments spend money on sending people into space, there is less to spend on helping people in need and on improving services for everyone. And so this is the reasonings that they're giving us to why space exploration is a waste of time. And it says scientists say that when they do experiments in space, they learn more about the universe, but their work would be more useful if it had made life better here on Earth. So it's also covering the grounds that scientists are saying that they learn more about the universe, but their work is not directly correlated to making life better here on Earth. And so that's why we need to find something that most weakens the above argument. And so we've got A, governments worldwide are increasing levels of education spending. B, work by space scientists on aviation has increased the safety of flying. C, the 1969 moon landing cost over $280 billion in today's money. And D, experiments on plants in space have shown that how we could grow them on other planets. So we need to find something that goes against this main idea, and actually says, no, hang on a minute, space exploration is not a waste of time. It's actually good for us. And so if we have a look, let's process of elimination this question. We've got A, governments worldwide are increasing levels of education spending. Well, we know this answer to question A is not really going completely against what this is trying to say. It's not directly weakening this argument. So it can't be A, because this is talking about how the government is spending more money on education. But is it really talking to us about why space exploration is not a waste of time? Not really. B, work by space scientists on aviation has increased the safety of flying. Now, this is actually weakening that main idea, because it's showing us how doing space exploration has actually improved our life here on Earth. So B is actually a weakening argument against this, that space exploration is a waste of time. Let's go through C and D. So C says the 1969 moon landing cost over $280 billion in today's money. In fact, this can be a weakening one, but it's more it can be a weakening argument because it's showing us how much money the 1969 moon landing cost, which is quite a very big amount in today's money. And so C could be a possibility, but remember, we need to find something that most weakens. And then we've got D, experiments on plants in space have shown how we could grow them on other planets. This is also a weakening point as well. But remember, boys and girls, we need to find out which one most weakens it. And remember, usually our evidence to most weaken it has to be directly related to the evidence that they've given us here. And so our answer that would most weaken this above argument is B. Work by space scientists on aviation has increased the safety of flying. And like I said, safety of flying, a majority of the world flies from one place to another, and we've always, throughout history, we've had many flight accidents where people have passed away and things like that. And so what space scientists have done, because they're flying to outer space and working in outer space areas, the safety of flying has definitely improved, and that can be applied to real life. And so that's why our answer to question 20 is B. And so this question, boys and girls, is an assessing the impact of additional evidence question, focusing on identifying weaknesses. And in the 2021 paper, question 32 was a very similar question to this, where both questions require students to determine the main point of an argument and figure out a statement that would most go against that argument, thereby weakening it. And both questions have similar fields of topics, okay? And so our answer to question 20 is B. Alright, so you can see here that your general knowledge has to be quite wide. So boys and girls, I highly recommend that you really try and build up your knowledge on very broad topics, okay? Alright, let's move on to question 21. So question 21 says this. At the start of the meeting, every member of the movie club gets one vote on the movie to be watched. Everyone must use their vote. The movie that gets the most votes is the one that is watched that evening. So this evening, there are 21 people at the meeting, and there are 5 movies to choose from. Now, Kate says this. The movie that we watch will need to get at least 5 votes. Samira says, if a movie gets 11 votes, then we will definitely be watching this. If the information in the box is true, whose reasoning is correct? So, once again, we've got Kate and Samira, our main characters, and they need to match the above information over here. And so, we know that this information is true, and we are trying to measure both Kate and Samira's argument and see if they're correct based on this argument up above. So, we need to first understand what the information up above says. So, there are 21 people in this meeting, and so 21 people, and there are 5 movies to choose from. 1, 2, 3, 4, and 5. So, movie 1, movie 2, movie 3, movie 4, and movie 5. Now, basically, every movie gets one vote of the movie to be watched, and everyone must use their vote. And the movie that gets the most votes is the one that's watched that evening. So if that's something that we would do in real life as well. So it's something that's quite relatable. Now, there are 21 people and there are 5 movies to choose from. And so Kate says this. The movie that we watch will need to get at least 5 votes. Well, if you think about it, boys and girls, if we've got, for it to be an equal chance, each one would have to get at least, there are 21 people, so it's an odd number of people. But if we actually did 21 divided by 5, that would be 4 remainder 1. And so to be equal, everyone would have to have 4 votes in each one, but then the last one would have that extra vote of 5, and that movie would be the majority, and so that movie would be watched. And so Katie's reasoning is actually correct, because they would indeed need to get at least 5 votes, okay? Now, Samira says if a movie gets 11 votes, then we'll definitely be watching it. And that's actually correct as well, because if you think about it, imagine that, I'm going to use blue here. Imagine that 11 people chose movie 1. That's actually more than half, okay? Because 21 divided by 2 is equal to 10 remainder 1. And so if there were only 2 movies that people really wanted to watch out of the 5, the one who would have that one extra vote would be the winner. And in this case, for example, here would be movie 1. Because it's more than half, the majority would win. And so that means even Samira's reasoning is correct as well. And so whose reasoning is correct? Our answer to this is C. Both Kate and Samira's reasoning is correct. Alright, so boys and girls, this is once again a detect reasoning errors insufficient reasonings question. And a very similar question to this was question 18. Both questions require students to work out whose statement is correct based on the given information in the box. Both involve a little bit of mathematical thinking to find the correct answer. So, these questions are quite difficult because you're not only having to logically follow them, but you have to apply mathematics as well to be able to get there. So our answer to question 21 was C. Okay, so let's have a look at the next question. Question 22. So question 22 says this. It says, a room measuring 3.2 meters by 3 meters is to be tiled with a pattern tile like the one shown below. So you can see here, this is the desired tiled pattern that has been given. Now it says the tile is square with a side length of 0.25 meters. So I'm going to write the information as we go. So we know it's a square. So I'm going to indicate that it's a square by drawing these lines, and it's 0.25 meters. Now it says the tiles are laid in lines from one edge of the room to the other. And it says the last line of the tiles will need to be cut for it to fit in. Which one of the following tiles shows how the last tile on the floor could look? Okay, so what we know is we've got this area that we need to fill in, and this is what the area looks like. Okay, so we can see that it's a bit of a rectangular in shape, as seen here, and you can see here that the bottom, one side is 3 meters, and so what we'll do is we'll do this side as 3 meters, and the other side is 3.2 meters. Now, what we can see is that because it's all in meters, it can be quite tricky to work with. And so what we're going to do is we're going to actually convert that. So the numbers are bigger and it's just a bit more easier to be able to divide as we work through these. So let's have a look. We're going to change, first of all, the 3 meters to 300 centimeters. And we're going to change the 3.2 meters to 320 centimeters. Now, one thing you need to know, boys and girls, is that 0.25 meters is also 25 centimeters. So always just remembering this fact that 100 centimeters is equal to 1 meter. Okay, so now that we know that, let's continue through. So we need to see what needs to be cut out, and then we'd be able to work through and then we need to choose our options. Out of the options, what will the last tile on the floor, what could it look like? And so if you have a look here, we can see that 25 centimeters will accurately fit into 300 centimeters. It will fit in perfectly. If you actually work it out, there are four lots of 25. So 4 times 25 is equal to 100. And so how much would equal to 300? You would have to go 12 times 25 to get to that. And so, yeah, if you actually work that out, you can see that there's 3 lots, because if you times this by 3, that works, and the other side times by 3, it will get to 300. Okay, so now that we know that this will completely fill in, nothing needs to be cut within here. So no cutting required on this end here. Okay, so I'm going to write here, no cutting required. Okay, so now that we know that, we've got this little section here which is 320 centimeters. So how does this work? Well, 320 centimeters, if we know that 300 works, we're left with that extra 20 centimeters, as you can see here. But we know that one tile is 25 centimeters. So what we're going to do is we need to find out how much of the portion needs to be cut to fit into like this last section within. And so we're going to actually break this down. Okay, so if this whole thing here is 25 centimeters, and we've got 1, 2, 3, 4, 5, all little identical squares within, we should be able to see that each section here is actually 5 centimeters. 5, 10, 15, 20, 25. So each section is 25 centimeters. So if we only need 20 centimeters, we know that the amount that is being used will actually only be 4 parts of it. So it could be looking like this, or it could be cut the other way around. Really depends. Okay, so now that we know that, what we need to do is we need to have a look at our option that shows this, and the only option that does show that, to see what the last tile on the floor could look like, would be our answer B. Okay, and so this question, boys and girls, is an identifying similarity measurement question. This question is actually not similar to any question in 2021. At first glance, it looks similar to the tile pattern questions of past papers, but it involves dimensions, which makes it more mathematical, requiring students' ability to work out area using width and length. And so it's a bit more, you've got to still use math, but then it's how you use the math that makes it a bit more confusing. All right, let's move on to the next question, boys and girls. So over on to question 23. Question 23 says this. It says, Lauren wants to join her school's basketball team. To qualify, players must be at least 140 centimeters tall. Okay, now Miriam says, Lauren was 139 centimeters tall last year, but she has now grown to be 141 centimeters tall. So she will definitely be chosen to be part of the team this year. Okay, and what we've got to do is we have to find out which one of the following sentences shows the mistake Miriam has made. So within this question, there is a little mistake that has been made, and we have to be able to identify that based on the information we're given. So once again, as usual, we need to see how does Miriam's opinion or statement that she's given follow this information up above here, if this information is always seen as true. Okay, so let's have a look. So Lauren, if we have to first understand this above information. So Lauren wants to join the basketball team. Now, to qualify, that's the key thing. To be able to make it in, players must be at least 140 centimeters tall. So to even qualify to be able to try out, I guess, she needs to be at least that much. And so we know that Miriam's saying Lauren was 139 centimeters tall, but she's now grown to be 141 centimeters. So she'll definitely be chosen to be a part of the team this year. Remember, the key word here was the word qualify. To qualify, to probably even try out or even be chosen is also other elements to be considered. And so if we have a look at our options, we've got A, Lauren might not actually enjoy playing basketball. Not very relevant, because in fact, the first sentence shows that Lauren does want to join the school's basketball team, so it can't be A. Then we've got B. There might not be enough players to form a complete basketball team. Well, that's quite an irrelevant answer to what Miriam is saying, and so that's why B is incorrect. Then we've got C. Height might not be the only thing used to choose players from the basketball team. And then we've got D. Other sports teams might also have a height requirement. Now, even if other sports have a height requirement, that's not really relevant to what we're doing now. So D is incorrect, and so then we're left with our only option to be C, and it is based on what Miriam's trying to say. There's a mistake in there. Height might not be the only thing used to choose players for the basketball team. Remember, the key word here was this word, to qualify. So to qualify, to even try out, that's one of the requirements, but there could be other things that have other requirements that haven't been mentioned yet. So that's why I answered question 23 is C. Now, this question is a detect reasoning error identifying weakness question, and a very similar question to this in the 2021 paper was question 21 as well. Both questions involve determining a flaw in a person's reasoning using the given information. So students have to identify the mistake in the individual statement. Both questions involve some level of mathematical thinking. The 2021 question 21 more so than this question that we're doing now. Okay, this one didn't really involve too much mathematical thinking, but it did still require you guys to be able to see the weaknesses within someone's statement. All right, let's move on to question 24. So question 24 goes like this. It says 3 switches are connected to a set of 4 lights. Okay, there's only 4 lights. Now it says when a switch is changed, each of the lights that controls turns on if it was off, or off if it was on. So essentially, you're thinking of like your normal light switches. There's only 2 functions. You either press turn it on if it was off, and if you flick it the other way, it's going to turn off if it was on. Okay, so relating that to what you know how a switch works, okay, a light switch. And so it says these are the 3 extra pieces of information that were given. Okay, so there's 3 switches and they're connected to 4 different lights. So it says switch 1 controls the red and green lights, switch 2 controls the red, green and blue lights, switch 3 controls the blue and yellow lights, and if all 3 switches are off, then all 4 switches are off as well. So you need to see how they're all related, and we're going to draw a little diagram to this. So we've got 4 lights. We've got red, we have green, we have blue, and we have yellow. So we've got all 4 different colors, and we've got 3 different switches. We've got switch 1, we've got switch 2, and we have switch 3. Okay, and so now we need to just see which one controls what. So switch 1 controls the red light and the green light, and switch 2 controls the, let's use black, red, green and blue light, and switch 3 controls the blue and yellow light. So we'll use this one, blue and yellow light. Okay, and so if all 3 switches are off, then all 4 switches are off. Okay, so you can see that, for example, well, that's all the information we're given. So we need to find out which one of the following is true. So they've given you a few scenarios, and we've got to try them out based on the information, the diagram that we've drawn here. So we've got A, it is not possible to have all 4 lights on. Well, hang on a minute. It is possible to have all 4 lights on, because if I just played around with, if I just tried out the different combinations, I would be able to do that. Because think about it, if all 3 switches are off, then all 4 lights are off. That means the opposite can also happen as well. And so A is possible, and so that's why this is incorrect, because it's false. It is possible, and this one is saying it's not possible. Then, because remember, we're trying to find out which one is true, so always referring back to this idea about it being true. B, the blue light cannot be on when the yellow light is on. Well, that's also incorrect as well, because if you think about it, if you have a look, this is also false. Because look here, switch 3 controls both blue and the yellow. So even if switch 2 was off and all of these were off, we can turn on switch 3 and then both of these would turn on at the same time. And so that's why B is incorrect. B is actually possible. The blue light can be on when the yellow light is on. Then let's have a look at number C. The green light cannot be on when the blue light is on. So the green light cannot be on when the blue light is on. Well, that's also incorrect as well, because following the same logic as B, we can see that it does work, because we've got green and blue both being controlled by switch 2. And so that's why C is incorrect. C is also false, and we need to find out which one is true. So let's have a look at D, and let's confirm that that is the statement that's true, because if that's also false, then we've done something wrong. So D, the red light cannot be on when the green light is off. So let's read it again. The red light cannot, so it can't be on when the green light is off. And I can say that this is true. How can the red light be on, can be off when the green light is off as well? That doesn't work, because both switch 1 and switch 2 both control the red and green lights. Okay, so that means the red light can't be on when the green light is off. They both have to be on and they both have to be off. And so that's why our answer to question 24 is D. Now this is a bit is quite confusing, boys and girls, because of the language that they use. It's saying cannot be on when the green light is off. So it's using like the different languages, and it's quite confusing because it's using like the negative language as well at the same time. So that's why it's a bit tricky, and you have to be really careful with your verbal reasoning when you're trying to do these kinds of questions. That's why it's really important to have a visual diagram to lead you and guide you as you're doing this kind of question. So that's why our answer to question 24 is D. Now, this question is a relevant selections verbal data processing question, and this question is actually not similar to any question in the 2021 paper. It involves the concept of consequence, cause, and effect as students have to work out what happens when each switch is turned on and off. So it's quite a new type of question that we're being exposed to in this paper. Okay, so let's have a look at question 25 now. So question 25 goes like this. It says, I have just 4 cards. Now, the cards I have a letter printed on each side. So think about like your card. A card usually is double-sided. There's one side and another side, and each card has that one letter printed on each side. Now, it says that the cards can be set out to make the following words. No letter appears twice on the card. So there's only one letter per card, okay? And from those letters, so altogether we actually would have 8 letters, okay? 8 letters, and within there we would have only 4 cards, and with that we would be able to make different different words. And so what we're going to do here is this. I'm going to actually write card 1, card 2, card 3, and card 4. Okay, and so drawing out these cards, and from here drawing out lines, okay, to show us that this is one side and this is the other side, and just to show it. Now, what we need to do is we need to now look and compare between each of these words to see what's common, what could each side be, and so forth. And so if we have a look, we're going to start off with coat and boat. Essentially, they're rhyming words, but you can see that O-A-O-A-T, they're all the same. Okay, so that means that, and remember, there is no repeating letters used. And so O-A-T, O-A-T the same. So that means C, B are actually related to each other. So we can write C, B immediately. And so we'll give that a circle and a circle so we can see that those two are related to each other. Now, what we're going to do next is this. We're going to actually look at another 2 pairs of words. We're going to look at lack and we're going to look at sock. Now, what do we see that's common? We can see that the C is common and the K is common, so we're going to actually eliminate those 2. Now we're left with L-S-A-O. Now, we need to see what kind of pairs come together with that, and we can assume that L can be with S, but L can also be with O. We just don't know yet. And the same thing goes for A. A could be with S, but A could also be with O. Okay, so we're just left with these 2 possibilities. And from those 2 possibilities, we're going to leave those 2 words, and we're going to actually compare these 2 words together now. So we're going to compare coat and lack together. Now, what we're going to do is once again find the common letters, and those common letters was A here and C, which was also here. And so all that's left is OT and LK. So OT and LK. So O could be with L, but O could also be with K. T could be with L, but T could also be with K. And it's a matter of finding out what's related. But we can see one commonality. From these 2 words that we compared, we saw that LO could have been a possibility. But then from these 2 words, we also saw that LO was also a possibility here. And so from seeing that, we can now determine that O and L are together. Okay, so we're going to circle all of those. So O and L are together. And we're going to write O, L. And so that means if O and L are together, and we had the common letters A, C here, that means we're left with T and K, and that makes our 3rd pair, which is T and K. T and K. So T and K now have a pairing. And so that leaves us with 2 letters, which is A and S. So A and S must be paired together. So we're going to write A and S together. Okay, so now we've got our 4 different card possibilities and what each side the letters are. And so we need to now know which one of the following cards words could be made using the cards. And so we've got bats, blot, cabs, and cost. So if we have a look, bats, we've got B here, A here, T here, but we've got S here. And you can't use two, like you can't have 2 cards at the same time. So that's why A can't be it. Because remember, boys and girls, if we want to be able to make a word, we have to use 1 letter from each side of the cards. We can't have 2 letters being used like that because we can't keep flipping it around. We have to show it visually like this. So it can't be A. Then we look at blot and see if we can make that B-L-O. No, because there's 2 letters on 1 card. So it can't be O. So let's look at the next one. Cabs, we've got C-A-B-S. Nope, that doesn't work because we'd be using only 2 cards to show that whole word, which is not possible. And the last one, we've got the word cost. So we've got C-O-S and T, and that works. So I'm going to highlight that C-O-S and T, and they're all on different cards. So our answer is D, cost. Now, boys and girls, this question is a identifying similarity arrangement question. And so this question is actually not similar to any questions in 2021. It appears similar to a code question at first. However, it is more focused on word formation like in the old GA papers. So that's why we see value in also practicing GA and being good with that as well, because you can see that it does lead into some of these thinking skills questions. Okay, so that's question 25. Let's move on to question 26. So question 26, let's have a look. It says, a school excursion to watch a musical at the theatre is scheduled to take place next month. However, it will be cancelled if fewer than 20 students sign up for it. On top of that, even if 20 students or more sign up, there must be enough teachers to accompany them. The school's policy states that there must be at least 1 teacher looking after every 10 students on an excursion. Okay, so there's actually a lot happening here. Now, Rowan says, as long as 2 teachers are available to accompany the students, the excursion can still go ahead. Megan says, if this excursion is cancelled, it must not be because not enough students signed up for it. So, we need to know if the information in the box is true, whose reasoning is correct. So, both of these students' reasonings, we have to determine if their reasonings are correct based on this information in the box, because this information in the box is true. Okay, so this is what we know. A school excursion to watch a musical is scheduled to take place. That's setting up the scenario, but not really important information to help us work out this question. It says, however, it will be cancelled. So the key thing is it will be cancelled. So will be cancelled if fewer than 20 students sign up for it. Okay, so if there's less than 20 students, and on top of that, even if 20 students or more sign up, there must be enough teachers to accompany them. And the school's policy states that it has to be 1 teacher looking after every 10 students. Okay, so that means there would need to be at least 2 teachers if 20 students sign up, but it has to be 20 or more that sign up. Okay, so there's actually 2 conditions that take place. This is condition 1. If 20 students, it'll be cancelled. So this is number 1, condition 1, and condition 2 is that there needs to be enough teachers. So there's 2 different conditions needing to take place. Now what Rowan says, as long as 2 teachers are available to accompany the students, the excursion can still go ahead. And so if we have a look here, that's Rowan's reasoning is actually incorrect. Why is it incorrect? Because even though there are 2 teachers that are available, that's not we need to know if there's enough students as well on top of that. And so that's why our answer to Rowan is incorrect. Okay, we can't guarantee that. Okay, and so that means let's have a look at Megan's reasoning. It says if the excursion is cancelled, it must be because not enough students signed up for it. Well, Megan is also incorrect as well, because remember, there are 2 conditions that need to take place. There's condition 1 and condition 2. Now, both of these students are wrong. Well, their opinions or statements are wrong because maybe the reason why it got cancelled was because of one of the state conditions were not fulfilled. And so whose reasoning is correct? Our answer is D. Neither Rohan or Megan's reasons was correct. Okay, so boys and girls, this question is a detect reasoning error question focusing on identifying arguments. Okay, and so a very similar question to this was question 33 in the 2021 paper, focusing on identifying arguments, detective reasoning errors, and both questions required students to work out whose statement is correct based on the given information in the box. Both questions involved some mathematical thinking, as well as there is a numerical criteria in both questions. Okay, numerical criteria, so focusing on a bit of math in within. All right, so that's question 26. Okay, so having a look at question 27. Question 27 goes like this. It says that 4 students were comparing how much they enjoyed English, history, and math. Now it says Emily liked math more than history, only Gemma liked English more than history, Wesley and Rohit both liked math more than English, no one liked history the least. Okay, so the question is, what is the maximum number of students who could have liked math the most? All right, so what we're looking at here is we've got four different statements, and from these 4 different statements we need to compare and rank their most favorite subjects all throughout. Okay, and so if we have a look here, it says Emily liked math more than history. Okay, so this is comparing, and boys and girls, what we're going to do is we are going to write from the most favorite subjects like this going down to the least like this. Okay, so just remembering that. So Emily liked math more than history, so math more than history, and that means her last subject that she's got is English. Now we don't know if English is between math and history, so we're going to just leave that for now. Now it says only Gemma liked English more than history, so only Gemma liked English more than history. Okay, and it says we don't know about math yet. Okay, now it says Wesley and Rohit both liked math more than English, so Wesley and Rohit both liked math more than English, and this last statement will help us work out what the ranking of the rest of the subjects are. It says no one liked history the least, so that means history can never be the third in all of these. Okay, so if we have a look here, Emily liked math more than history, that means English can't be between them. English has actually got to be over here. And it says only Gemma liked English more than history, that means that math is down below because history can't be the least liked subject. And Wesley and Rohit both like math more than English, that means that history is actually got to be between math and English, because remember, history is never the least. And so the question is, what is the maximum number of students who could have liked math the most? Well, if we have a look here, we can see that Emily liked math the most here, and both Wesley and Rohit liked math the most as well. And so that's 1, 2, 3. Our 3 students is the maximum number of students who could have liked math the most. And so our answer to question 27 is C. Now, question 27 is a drawing conclusions, making a conclusion question. This question is actually not similar to any question in 2021, and it involves working out the preference of individuals and ranking them to work out who has a preference for a particular subject, okay? And so our answer to question 27 is C. Okay, so let's have a look at question 28. Question 28 says this. It says 5 keys are placed on a glass table. Now the image below shows the view of the table from above. Okay, so think of this as a top view, boys and girls. We're looking at it down, from above down. So I'm going to write top view here. Okay, now it says which one of the following is a view from under the glass table? So boys and girls, this is going to require a lot of visualization skills, but it's also got to involve you guys to really look at the really close details, because from each of your options there's probably going to be like 1 or 2 things that are incorrect, and that will and some like a small mistake can cost you this mark. Okay, can cost you 1 mark. So One thing you need to remember, boys and girls, is that if you're looking at it as a top view, you're looking at it from above. Now you need to ask yourself, if I looked at it underneath, my view would be quite different, okay? And so you need to imagine what would it be like, and rather you can see that it would actually be a mirror-like image, or it would be completely flipped in terms of view. So think of it as being flipped down below like this, okay? And so now that we have identified what it should look like, we need to look at our options very carefully to determine that. And so I will say now the answer is B, and it's a matter of now seeing why it couldn't be A, C, or D. And so if you have a look at A, boys and girls, you'll notice that most of it has actually been flipped quite accurately, except for these ones here. And so you can see here that both of these keys are not the correct accurate form of what it should look like. And so we can see that our answer cannot be A. And then if we have a look at C next, we can see that C, once again, the one that hasn't been accurately flipped is one of the keys down below here. And so in saying that, we can see that it cannot be, this bottom key is not flipped properly, so it can't be C either, so not A or C. And even with D, it cannot be D because this middle key has not been flipped properly as well. And so that means we're left with only one option, our answer to question 28 being B. Now, question 28 is a identifying similarity arrangement type question, and a very similar question to this was question 40, which was an arrangement question as well. Now, both of these questions require students to visualize a view that is different from the one presented in the question. However, the 2021 question 40 involves a 3D object, while the 2022 question 28 involves essentially a 2D view, and students are to find a reflected view of it. So like we said, a mirror or flipped image of this. So that's question 28. All right, so let's have a look over to the next page, question 29. So question 29 says this: when players are dropped from the school football team, it is usually because the coach thinks they have not been playing well enough. Now, sometimes a player will be dropped for not attending training every week as well. Now, Kylie says, the coach said that she's going to drop Katya even though she's been playing well. She can't have been coming to all the weekly training sessions. Fiona says, if she came to the sessions and started playing even better, the coach definitely wouldn't drop her. Alright, so if the information in the box is true, whose reasoning is correct? Once again, boys and girls, we need to look at these two people's reasonings and we need to base it, see how they match according to the information in this box. And then we can determine if it's true or false, okay? And so what we know is this. Players are dropped from the football team. It is usually because the coach, number one, thinks they have not been playing well enough. So that's condition number one. And sometimes a player will be dropped for not attending training every week. So there are actually two conditions, okay? It doesn't have to always be those two, those conditions work together, but they're two conditions regardless. And so Kylie, let's analyze each person's argument. So Kylie says, the coach said that she's going to drop Cardia even though she's been playing well. She can't have been coming to all the weekly training sessions. Now, is her reasoning correct? Well, Kylie's reasoning is incorrect, okay? Because we don't know how, we can't really measure the scope of what it means to play well. That's entirely up to the coach's decision. So even though she's been playing well, she can't have been coming to all the weekly training sessions. We're not too sure as well with this. And so that's why Kylie's reasoning is incorrect, okay? And so let's have a look at Fiona's reasoning as well. Fiona says if she came to the sessions and started playing even better, the coach definitely wouldn't drop her. And so if we have a look here, even Fiona's reasoning is incorrect as well. Because once again, we don't know. There could have been another reason why as well, because key thing here, another thing is to do with modality with the words. It says it is usually because. We don't know, there might have been another factor as to why the coach dropped her from the football team, and so that's why Fiona's reasoning is wrong, because she's saying that the coach definitely dropped her for this reason. And so whose reasoning is correct? Our answer to this is D. Neither Kylie nor Fiona's reasoning is correct. Boys and girls, this question is a detect reasoning errors, analogies and anecdotes question, and question in the 2021 paper, question 38 was a very similar question to this. In both questions, the two individuals are referring to a third party. Students have to deduce whether each individual statement has correct reasoning within. So that's the answer to question 29. Let's have a look at question 30 now. So question 30 says this. It says that solid glass can actually be better described as a slow-moving liquid. The particles in glass can move just like in a regular liquid because they are not fixed in an orderly structure. In glass, this movement is so slow that it cannot be detected during a person's lifetime or even over the course of several generations. Medieval window glass, which has survived to the present day, is often found to be thicker at the bottom than at the top. This clearly shows that glass flows. Which one of these statements, if true, most weakens the above argument? So the key thing here is we're trying to find a weakening statement, okay? So we've been given an argument and we need to now find which one of these will help weaken this argument. So essentially, remember, boys and girls, when we're doing weakening arguments, we're finding something that disagrees with this. Okay? And so we need to find something that most disagrees with this, which means it does not support what this is saying. So let's first identify the main idea here. Now, the main idea here is that glass flows, okay? That's their main idea, that solid glass can actually be better described as a slow-moving liquid. Now, the reasoning that they give is that it talks about how they're not fixed in an orderly structure. The movement is so slow that it cannot be detected during a person's lifetime. And medieval glass, which has survived to the present day, is often found to be thicker. So this is the evidence as well, to be thicker at the bottom than at the top. Now, we need to find which one of these statements actually weakens this, and it says most weakens because there might be a few that weakens this idea. And the key thing is, boys and girls, when you're trying to find the evidence that most weakens it, it needs to be relevant to the evidence that they give within here, not an entirely new idea. Okay, and so if we have a look at our options, we've got A, glass can be melted, and melted glass, like every liquid, flows and obtains the shape of the vessel into which it's poured. Okay, so glass can be melted, and melted glass, like every liquid, flows and obtains the shape of the vessel which it is poured. That's an extra fact, but is it disproving to us that glass flows? Because remember, we're trying to find a weakness that says no, glass does not flow. Glass is not a liquid. So A is not really helping with that. Then we go on to B. The human eye cannot detect tiny differences in the thickness of glass. Well, even within here, the human eye cannot detect tiny differences in the thickness of glass. Well, if this is not really helping to weaken this idea that liquid glass flows, or glass is a liquid, so it can't be B either. Then we're having a look at C. Modern buildings such as skyscrapers are often constructed from glass. Essentially, this is a bit of a irrelevant idea because, yes, modern buildings are constructed from glass, but how is that actually telling us, disproving to us why glass is not a liquid? Then we've got D. Glass objects from ancient Egypt or Greece which have remained untouched for millennia are not thicker at the bottom than at the top. And so you can see that D is our weakening statement that helps weaken the above argument, because the evidence that they've given as to why glass is a slow-moving liquid is because in medieval window glass, it's thicker at the bottom than at the top. But they're showing to us that in ancient Egypt or Greece, which was a very similar time period or even before then, it is not thicker at the bottom than at the top. And so this is direct evidence proving as to why glass is not a slow-moving liquid. Therefore, our answer to question 30 is D. And so, boys and girls, in this type of question is an assessing the impact of additional evidence question category, and it's about identifying weaknesses. Now, a very similar question to this is in the 2021 paper was question 5, where both questions involve determining a flaw in a person's reasoning using the given information. Students have to identify the mistake in the individual statement. Neither question involves any math. Okay? All right, let's move on to the next question, question 31. So, question 31 goes along the lines of this. It says, Alice is having some fun typing dates into her calculator. Now, she types them in the format DD, So, in case you don't know this, DD is your days, MM is your months, and YYY is related to your year. So that, for instance, the date 7th of March 1996 is entered as follows. So you can see here, we've got our day, we've got our month, and we've got our year. So it says, when Alice enters the date 12th of February 2021, she notices that it reads as the same date when she turns the calendar upside down. So which of the following other dates will she read as the same date when the calculator is turned upside down? So first of all, let's actually write 12th of February 2021 as though it's in a calculator. So 1, 2, 0, 2, 20, 21. And so if we read it this way, we can definitely see it says 12th of February 2021. And if we actually turn it around as well, it actually goes 12th of February 2021 and upside down. It actually reads that way. So that actually works. Now what we've got to do is we've actually got to go through and see which of the following does the same thing when it is turned upside down. And so this really does involve a bit of similarity, but also a visualizing question as well, because we have to flip it to see if it works. So if we have, let's write the dates down. So we've got 19, so as though it's a calculator, 1901, 01, apologies. Let's rewrite that again. 1061, and if we turn it upside down, that actually works. So we're going to give it a tick, but we do need to try out the others. So we've got 2, 6, 6, 1, 1, 1, 9, 9, 2. And if you have a look, it starts to work. 2, 6 works, but 6, 1, that doesn't work, okay? It doesn't create the 1, 1, so it can't be B. So let's try the next one, 20th of February. So 2, 0, 0, 2, 2, 0, 2, 0. And we can immediately see it doesn't work because it starts with a 0, but we're meant to start with a 2, so it can't be C. Then we've got D, which is an 8th of March, so 8, 0, 8, 0, 3, and then 3, 0, 8, 0, 0, 8, 0 kind of works, but then you can see here that the 3 becomes upside down and it doesn't read as a 3, but rather as, you can see here it doesn't work, and so our answer is not D either. Okay, and so our only option that we've got is A, 19th of January, 1061. Okay, so that's question 31. Let's move down to, before we move on to question 32, boys and girls, question 31 is an identifying similarity arrangement question. A very similar question to this was question 37 in last year's paper. Both questions involve transformation. This year's paper is about flipping the figure upside down, while question 37 last year is about a series of transformations in a pattern. Last year's question is more about figuring out the pattern, while this year's paper is finding a date that matches the criteria of the question. So it's actually quite a fun question, if you ask me. It's a fun question that that once you understand it, it's quite it's not as daunting and hard to solve. Okay, and it's definitely doable within a minute once you understand how to do this kind of question. Okay, so let's have a look at question 32. Question 32 says this. 6 friends are standing in a circle in the playground facing inwards. Grace is standing to the left of Catherine and is opposite Willow. Max is facing Carrie and is standing next to Catherine. Liam is in between Willow and Carrie. Now, they've been playing a game in which they throw a beanbag to one another in a specific pattern. Someone throws the beanbag to the person opposite. They then hand it to the friend on their left. In the first round, after 3 repetitions of this pattern, Willow is holding the beanbag. So who was holding the beanbag at the start? And we've got our 4 options here. So what we've got to do is we've got 2 pieces of information. Now, before we can even work out who was holding the beanbag at the start and work out this game, we actually have to first work out the placement of these 6 friends. So what we're going to do is we're going to draw a little circle and then we're going to work this out. So first of all, we know that Grace is standing to the left of Catherine and is opposite Willow. So we're going to start off with Grace. We can place Grace anywhere because it's a circular pattern, and is standing to the left of Catherine. So we are going to assume Catherine is over here and is opposite Willow. So that means Grace is opposite Willow. Now, we also know that Max is facing Carrie and he's standing next to Catherine. So Max is standing next to Catherine and is facing Carrie. So that means Max and Carrie are opposite to each other. And we've got that one last friend, and we can check if this is correct. Liam is in between Willow and Carrie, which is exactly correct. So now we've just worked out the placement. What we're going to do is now we're going to have a look at the game itself. It says they've been playing a game in which they throw a beanbag to one another in a specific pattern. Someone throws the beanbag to the person opposite. They then hand it to the friend on their left. In the first round, after 3 repetitions of this pattern, Willow is holding the beanbag. So who was holding the beanbag at the start? So we know that Willow was the one who ended up with it. But what we've got to do is we've got to work out who started with the beanbag. And so what we know is that the way that this game works is that if Grace had it, Grace gives it to the person opposite her, and then that person hands it to the person that's on their left. And so you can see how it works. It goes down and then to the left. Now what we've got to do is we've actually got to work backwards, because we know the end result is at Willow, but we have to work backwards. So we actually have to go to the right and then give it opposite. Okay, so for example, the example that I showed you, Grace to Willow, Willow to Max, Max would hand it back to Willow, Willow would give it to Grace. So it's kind of going to the right and then opposite. All right, so let's try and follow this. So if Willow has it at the end, we know that step 1, Willow would give it back to Liam, and then Liam would give it to Catherine. So that's the first repetition. Remember, there are 3 repetitions to follow. Now, the second repetition would be where Catherine gives it to Max, Max gives it to Carrie. So that's number 2. And then the third repetition is when Carrie gives it to Grace and Grace gives it to Willow. So that's our third repetition. So who was holding the beanbag at the start? We can see that Willow was holding the beanbag at the start. So our answer to question 32 is C. So you can see here, boys and girls, there are actually 2 pieces of information you need to work out to be able to then work out the actual question. So this is the first thing, and then you needed to work out through to the next part here. So if we have a look, we know that question 32 is a verbal data processing relevant selections question. Now, this question is not similar to any question in the 2021 paper. It involves similar skills to some mathematical reasoning questions with the circular table arrangement. However, it also introduces a new aspect, which is the movement of a beanbag around a circle. And you really needed to understand the language involved in there to be able to work this out. Okay, and so ultimately students have to figure out where the beanbag ends up. So that's question 32. All right, let's move on to the next question, which is question 33. So question 33 says this: Matt and Yash play chess together every day at lunch. They are at around the same skill level and they have each won around half of the matches. They've played against each other. So it's not the first time they've played against one another. They've played against each other many times. Now, Mr. Steed says this, or Mr. Stead: I can't remember how many games Matt and Yash played last week, but I know Matt won 5, so they must have played about 10 games. Now, which one of the following sentences shows the mistake that Mr. Steed has made? So once again, Mr. Steed has made an opinion, and we need to check if that matches the information up above, because this information is regarded as true and always correct, okay? And so if we have a look here, let's analyze this. We know that Matt and Yash always play chess together, and they are at around the same skill level, okay? And it says they have each won around half of the matches that they've played against each other. Now, is this the half the match, they always win around half the matches they've played against each other per day, or is it in their lifetime, or in the time that they've all played together, duration? So it could be months or years that they've played against each other. So now that we understand this, let's try and analyze this. So Mr. Stead says, I can't remember how many games Matt and Yash played last week, but I know Matt won 5, so they must have played about 10 games. Now, there's a mistake in Mr. Stead's reasoning. Let's go through them. We know our answer to be A, or if we go through it, we've got A, either Matt or Yash might have played unusually well last week. We've got B, the players have each won around half and not exactly half of their games. C, Matt and Yash may have had lots of homework last week. And D, it doesn't matter who wins because the important thing is that they both have fun. So let's do a process of elimination, even though we know the answer to be A. And I'll explain to you why it's A. So B, the players have each won around half, not exactly half of their games. Now that could actually be a valid point here. But remember, we are focusing on last week, and we know that Matt won 5, but we don't actually know, like, there isn't enough information to tell us how, like, if this was the case, okay? And so there are many other variables that are involved. So this is not strong in, like, this is not a really particular reason as to what the mistake Mr. Stead has made. So it can't be B. Now, if we have a look at C, we've got Matt and Yash may have had lots of homework last week. Now, this is a bit of an irrelevant idea because that's not telling us nothing's mentioned within the information up above and all what Mr. Stead is saying within. So it can't be C. Then we've got D. It doesn't matter who wins because the important thing is that they both had fun. Well, this is not really relevant either because we're trying to figure out the amount of matches won or the games that were played. And so that's why A would be our best answer. That's the mistake that Mr. Stead has made because either Matt or Yash might have played unusually well last week, which is why Matt won 5 matches out of possibly possibly 5. We don't know. There's too many unknowns within here for us to really determine the correct answer to this. So that's why the best and most accurate mistake that Mrs. Stead has made is our answer A. And so, boys and girls, this question is a detect reasoning error, analyzing arguments question, and a very similar question to this was question 3 in the 2021 paper, where both questions involve determining a flaw in a person's reasoning using the given information. Students have to identify the mistake in the individual statement. Both questions involve some sort of math as well. Okay, and so our answer to question 33 is A. Okay, so let's have a look at question 34. Question 34 says this: Jody and Todd frequently message each other in code. Now, they always use the same code in which each letter of the alphabet is always represented by a unique symbol. For example, Jody is dollar exclamation at equals, and Todd is upper sign exclamation at and at. Now, when Todd asked Jody to name her favorite season of the year, she replied with this. So what is Jody's favorite season of the year? Okay, so what we're going to do is we're going to just write down the corresponding letters. We've got Jody, and Jody stands for the following symbols. And then we've got Todd here, and Todd stands for the following symbols as well. Okay, now, if we have a look here, there are 6 symbols over here. That means 6 symbols represents 6 letters, okay? And so if we have a look here, we've got the following words here, and they all have 6 letters, Okay, 6 letters, 6 letters, 6 letters. So we can't really eliminate anything within here. But if we notice the letters or the code, the symbols here, there is nothing that repeats, because if you notice, they always use the same code. So once you can crack this code, you'd be able to recognize or read any of the messages that Jody and Todd hand to each other, because the code is always the same. And so if we have a look here, we've got double letters here and a double letter here and here. So for summer and autumn, we can immediately eliminate that. Now, on top of that, winter has the letter T and Todd starts with the letter T, and we don't see this symbol at all over here. So we can actually eliminate D as well, which is why we're left with our only option as A, spring. And so you can see here that 34 is an identifying similarity arrangement question, where both and a very similar question to this in the 2021 paper was question 17, which was a making conclusions relevant selection question, where both questions involved deciphering a code. In last year's question, the code is made of numbers, while this year's code is made up of symbols. In both questions, students have to decipher the code to work out English words. However, in last year's question, the question asked for which words is ambiguous, while this year's question, the question just asks for the word to be deciphered. So you can see there are some similarities and differences within. Okay, so let's have a look at question 35. So question 35 goes like this. It says, the code to open a door in a computer game is a sequence of 4 pictures in a row. You have found the following clues about the code. It says, the bell is next to the book, the apple is somewhere between the bell and the cat, and the book is somewhere to the right of the cat. Now, you have to choose one of the 4 possible questions to ask. When the question has been answered, you must deduce the code. Which one of the following questions would allow you to deduce the code? Okay, so basically, if we understand what scenario is happening here, we have 3 different codes. We've got 3 different clues. Clue 1, clue 2, and clue 3. And these clues will help us to open a door in a computer game. And it's a matter of being able to crack this code and to be able to progress through. But the thing is, we have 4 possibilities of questions to ask, and we need to be accurate to be able to ask one. And once we ask that one question, we are able to deduce the code. And so the main question here is this: which one of the following questions would allow you to deduce the code? Okay, so what we've got to do is we've got to work through which of these questions do we need to ask, and which of these questions we need to ask. And so let's see what we know so far, okay? If we have a look at clue number 1, it says the bell is next to the book. Now, the bell can be next to the book either on the left or the right side. So if I actually wrote this down or drew this, the bell could actually be here, or it could actually be on this side as well. So we've got bell here and we've got the bell on this side. Now we know that, so we've actually got 2 different possibilities, okay? It could be on the left or it could be on the right. Now, clue number 2 says that the apple is somewhere between the bell and the cat, and the book is somewhere to the right of the cat. Now, what we can start off with is clue number 3, because there's a direction given to us to help us solve this question, okay? We can see that the book is somewhere to the right of the cat. So, if the cat is here, the book is somewhere to the right. Right is on this side, so we can write the book over here. So this is what we've been given. Now, what we have is we need to now include the rest of these information. Now, what we know is that the bell is next to the book, but we don't know where. So we can actually have 2 options. We've got option 1 and option 2. We can have the bell on this side, and we can either have the bell on the other side. So we're going to write this combination again. Cat, book, and bell. And then finally, let's incorporate clue number 2 within. It says the apple is somewhere between the bell and the cat, okay? So if we have a look, we can have the apple over here, and between the cat and the bell and the cat. So if the bell and the cat's here, and that means the apple could also be here. And so if we have a look, we need to find out which one of the following questions would allow you to deduce the code. And so we've got options A, B, C, and D, and we need to choose which one would would help us crack this code. And so let's go through this. A, is the apple next to the book? Well, if we are able to see if the apple is next to the book, we'd be able to then determine we'd be able to then see if it is option 1 or option 2, okay? Because if we find out where the apple is, if it's next to the book, directly next to the book, that means the bell would be on this side. But if it's not, that means then the most possible option would be here. Because if that's a no to this question, then the bell would be on the left-hand side of the book rather than the right. So A is our answer, but let's have a look at the next one. B, is the cat next to the apple? Well, this is not really a question that's necessary because we can already see that the apple is next to the cat. So it's not that would be a waste of a question to ask. If we have a look at C, is the bell next to the cat? Well, as you can see here in our two options that we've already drawn out, the bell is not next to the cat. So a bit of a waste of a question as well. And then we have a look at D, is the book next to the cat? Well, we can see here that between, we know that that's not an answer to be, that's not even a question to be answered because the book is nowhere, well, between the book, there's always something in there, okay? And so that's why our only option is going to be A. This is the only viable question to ask to then be able to deduce the code. That's why our answer to question 35 is A. And so question 35 is an identifying similarity question, arrangement question. And this question is not similar to any question in 2021. It involves both deciphering a code and working out order and position. And so the question requires students to determine which option will give them the additional information required to solve the question. This question does not appear similar to any written by the tutors previously either, and so this is something that's quite new. And so just being familiar and working through questions similar to this will help you to really understand the method to solve these kinds of questions and seeing the logic behind it. Alright, so that's question 35. Let's move on to the next part, question 36. So question 36 goes like this. It says, although many birds are fiercely territorial, they are typically very sensitive when nesting. Okay, so if they feel their nest has been disturbed, they often abandon it altogether, even if the female has already laid her eggs. Now, Lorenzo says this: my dad accidentally disturbed a nest when he was cleaning the roof, so there's a good chance it may now be abandoned. And Katerina says, there's an abandoned nest in the pomegranate tree in our garden that must have been disturbed too. If the information in the box is true, whose reasoning is correct? Alright, so remember, boys and girls, the information in this box is always true, and Lorenzo and Katerina, their reasonings, we have to see if their reasonings are correct based on this information in the box, okay? And so, if we have a look, let's work this out. Although many birds are fiercely territorial, they are typically very sensitive when nesting, okay? And so, we can see here that we've been given a little scenario, okay? They become sensitive when nesting. Not completely necessary, but it helps us set the scenario up. Now, this is where the important information is. If they feel their nest has been disturbed, they often abandon it altogether, even if the female has already laid her eggs. Okay, so that's the key. This blue part is the key information. Okay, if they feel their nest has been disturbed, they often. So keyword here as well is the word often, because it's saying that they most of the time abandon it, but it's not always the case. Now, Lorenzo says this: my dad accidentally disturbed the nest when he was cleaning the roof, so there's a good chance it may now be abandoned. Well, we can see here that Lorenzo's reasoning is actually correct, because he's saying that there is a good chance it may now be abandoned because it was disturbed, whether it be by accident or on purpose, as he was cleaning the roof. And so that's why Lorenzo's reasoning is correct, okay? So there's a good chance it may now be abandoned. That is a correct Lorenzo's point of view is correct, and it's following the information up above. Now, if we have a look at Katerina's reasoning in detail, it says, there's an abandoned nest in the pomegranate tree in our garden that must have been disturbed too. Now, Katerina's reasoning is incorrect, because in actual fact there could have been other reasons why that nest was abandoned. Maybe, and we don't even know if it was even a bird's nest, it could have been another animal's nest and so forth. And so there isn't enough clear information for us to deduce, or for Katerina to deduce, that it was a disturbed nest by a bird. And so that's why we can see that our answer to question 36 is A. Only Lorenzo's reasoning is correct based on the information given in the box. Alright, so our answer to question 36 is A. Okay, over to, if we have a look at question 36, boys and girls, we can see that question 36 is a detect reasoning errors question, which focuses on identifying arguments. Now, a very similar question to this in the 2021 paper was question 6, where both questions require students to work out whose statement is correct based on given information in the box by identifying any flaws in their reasoning. Both questions also refer to the same topic of animals. Okay, so let's have a look at question 37. Question 37 goes along the lines as this. It says there are 6 coins in a collection. Now it says there are 3 large coins and there are 3 small coins. For each size of coin, there is 1 coin with a circular hole in the middle, 1 with a square hole in the middle, and 1 with a star-shaped hole in the middle. Now, each coin is kept in a box. All the boxes are the same size. Each box has 2 symbols drawn on it. One of the symbols identifies the size of the coin and the other determines the type of hole in the coin, but they may be in either order. Now it says the box for the large coin with a circular hole has the symbols omega and E on it, and the box on the small coin with a whole square hole has the symbols pentagon and triangle on it. A third box has the symbols diamond and pentagon on it. Which coin could be placed in the third box? Okay, so what we need to do is we need to slowly break down this question. There's a lot happening here, so we've got to do this one by one. What we can see first of all is that there are 6 coins, okay? We've got 3 large ones, and we've also got 3 small ones. Now, in each of the 3 large ones, we've got 3 different shapes, okay? So we've got a circle, we've got a square, and we've got a star. And in the small ones, we've also got a circle, we've got a square, and we've also got a star. So we've got 3 different, and they're all very unique, each one. Now, what's happened is that they're all been put into small boxes. Well, 3 of them have been put into boxes. Now, on 3 of them, there is a symbol on them to identify which one is which, okay? So, and they may be in either order, so we don't actually know. But what we know is that one of the symbols identifies the size of the coin, and the other determines the type of hole in the coin. But the key thing is that they are in either order, so they're in randomized order. Now this is for one box, box 1, and this is for the other box. Now if we look at box 1, it says the box for the large coin with a circular hole has the symbols omega and E on it, okay? So we've got large coin with a circular hole has omega and E. So let's write that down, omega and E on it. And for the second box, it says the box for the small coin with a square hole. So for this one here, we've got a pentagon and a triangle on it. Now it says a third box has the symbols diamond and pentagon on it. Which coin could be placed in the third box? Okay, so what we've got to do is we've got to use the clues that have been given in here to help us solve what this one could possibly be. And so if we have a look, the box for the large coin with a circular hole has these 2 symbols and these 2 for the second one. Now, key thing is we notice that there is a similarity for 2 of them. We've got one for the pentagon and it's shown in box number 2. So, but we don't actually know what it stands for, because remember, it could either stand for size, so it could either stand for size, or it could either stand for shape. But we know that this could either be for a small coin or for a square hole, okay? We don't actually know. It could be for small or for square. So that means we can slowly go through our options and eliminate the one that doesn't have small or square in it, okay? And so we can see here that A has square in it, so we're going to still keep A as an option. B doesn't have square or small in it, so we can actually eliminate B. Now if we have a look at C, we've got the small coin with a circular hole, so we've got small here, so that's possible, and we've also got in D the small coin with a star shape, so C and D are still in the picture. Now if we have a look next, let's look at box number 1. Now, box number 1 has large coin and circular hole, and it's got an omega and E, and none of that is used in the third box here. That means it can't be, box number 3 cannot be large or circular. And so that means we can slowly eliminate any option that has large or circular in there. So we can eliminate A and we can eliminate C. And so that means we're left with only one option left, which is D, the small coin with a star-shaped hole. And that would be our only option left over. So therefore, our answer to question 37 is D. Now, boys and girls, this question is a identifying similarity, making conclusions question. And this question is not similar to any question in 2021, and it requires students to match symbols and categorize the coins into boxes based on the given information. And what you need to know is you have to use the available information you're given already to be able to help you solve the rest of these questions. That's why our answer to question 37 is D. Okay, having a look at question 38, let's have a read of it. So question 38 says this: in an athletics competition, there are 4 heats and every participant runs in 2 of the heats. The finalists are all of the participants who finished in the top 2 in at least one of the heats. Now, Chloe says this: Tim was faster than Leon in the first heat, so if Leon qualifies for the final, so will Tim. Which one of the following sentences shows the mistake that Chloe has made? And we've got our 4 options down below. Now, once again, boys and girls, we can see that this question we need to solve this question. What we need to do is we need to read this information in the box, and we need to make sure that this what is said here follows through with what's written up there. Okay, so we can determine if Chloe's reasoning is correct or incorrect based on if she follows this information up here. So basically what we know is this: in an athletics competition, there are 4 heats and every participant runs in 2 of the heats. Now, this is another piece of important information. The finalists are all of the participants who finished in the top 2 in at least one of the heats that they participate. So they technically get 2 chances to make it into the top 2, and then they can go into the finalists position. Okay, and so we've got 2 different rounds, and they just need to make it into the top 2, first or second, in at least one of those 2 heats that we have. Okay, and so this is what Chloe says: Tim was faster than Leon in the first heat, so if Leon qualifies for the final, so will Tim. Okay, so if we have a look here, we can acknowledge that yes, Tim was faster than Leon in the first heat that they ran, okay? But how do we not know that Leon came last and then Tim was in front of him? What if Leon was here and this was Tim? But there is 2 other people in front of them. We don't know that for sure. And so, if Leon qualifies for the final, so will Tim, but we don't know. There isn't enough information to really clearly show us this, because we don't even know what place Leon came for, and we don't even know if in the second heat they how they qualified, like if they even competed in the second heat and what was the result of that. And so, which one of the following sentences shows the mistake that Chloe has made? A says Tim may not run as fast in his other heat, which may be true, but for the beginning we don't even know what place Tim and Leon came in the first heat. So A is incorrect. That's not really the mistake that Chloe has made. B, Leon may not race against Tim again in his other heat, but that's not really showing the mistake that Chloe has made in her reasoning, so it can't be B. Then we've got C, Leon may qualify based on his performance in his other heat. And then we've got D, Tim may have had more chance to practice for the competition than Leon. Well, D is incorrect as well, because this is irrelevant to this information, to this question. And so our answer could be C, Leon may qualify based on his performance in the other heat. Because first of all, we don't even know if Tim and Leon competed in the second heat together. What if they were in 2 different heats? We're not even too sure about that. And so that's the mistake that Chloe has made in her reasoning about Leon and Tim. And so our answer to question 38 is C. Now, if we have a look here, question 38 is a detect reasoning errors question focusing on identifying weaknesses. And this is very similar to question 21 in the 2021 paper, which is also about detect reasoning errors, identifying weaknesses, where both questions involve determining a flaw in a person's reasoning using the given information. Students have to identify the mistake in the individual statement. So that's question 38. Okay, so let's have a look at question 39. Now, question 39 goes along the lines of this. P, Q, R, S, and T are friends. They all have either blue eyes or brown eyes. They each enjoy two of the following four activities: fishing, reading, playing the piano, and drawing. And so we've got here some clues to tell us who likes what. P likes reading and fishing, Q likes playing the piano and fishing, S likes drawing, everyone likes fishing except one person with blue eyes, everyone with brown eyes likes reading. Which one of the following statements must be true? And so we've got our options A, B, C, and D. So what we're going to do is we're going to actually put this into a little table to show us, to help us visualize our information better. So we've got P, Q, R, S, and T. And these are the following activities that we have. We've got fishing, we've got reading, we've got playing the piano, and we've got drawing. And so what we can see here is our different. What we're going to do is we're going to now fill this in. And remember, they only need to like 2 out of the 4 activities listed. So what we know is that P likes reading and fishing. And so we're going to tick reading and fishing, but not piano or drawing. Now Q likes piano and likes fishing, but that means reading and drawing, not so much. S likes drawing, and that's all we've been given. And then what we've been given is 2 other clues. Everyone likes fishing except for one person with blue eyes. Okay, so what we know is that we don't know R, S, T. We actually don't even know any information about R, and we don't even know any information about T. But that's all we know so far. And we also know that everyone with brown eyes likes reading. And so if we have a look here, everyone with brown eyes likes reading. That's a key statement, okay? Because if we know that everyone with brown eyes likes reading, then we can actually assume that that the others could have brown eyes because they like 2 out of the 4 activities. And so that might, going the opposite, would actually show us that some people with blue eyes might not like reading. And so that might actually show us that Q actually might have blue eyes. So we're going to circle that in a bit of blue there. Now, we need to find out which of the following statements is true. And from here, we can actually determine everything else, okay? So, A, there are more people with brown eyes than blue eyes in the group. That could be a possibility because if you think about it, that might be a possibility, but we're not too sure with that one. And then we've got B, Q and S have blue eyes. Now, as you can see here, half of that statement so far is correct because Q, we can see, has blue eyes based on the second clue that everyone with brown eyes likes reading. So that makes it logical to think that people with blue eyes might not like reading. And so that's why Q could be a possibility. And then C says P and Q have brown eyes. Well, we've already determined that Q could have blue eyes, so we can actually eliminate C. And we've got T likes reading. Well, we're not too sure about that as well because this one is based on a lot of assumptions. And so if we have a look at these, which one of the following statements must be true, we can determine that B is our correct answer. Q and S have blue eyes. Now, I'll also explain why that may be the case. Let's assume that that S, because they like one of the activities, let's assume that S has brown eyes. So if S has brown eyes, and I'm going to give that a tick to show that, that means that everyone likes fishing. That means that S would also like fishing as well. But then if you have a look here, if S has brown eyes and likes fishing, everyone with brown eyes likes reading, that wouldn't make sense because remember, you can only enjoy 2 of the following 4 activities. And so that tells us that that's not a possibility. You can't, that doesn't work, because if you see, everyone with brown eyes likes reading, but if we're assuming that S has brown eyes, that means that that means everyone has to like fishing as well, because everyone likes fishing except for the one with blue eyes. So that doesn't work. So that means that we can assume that S actually has blue eyes. Let's circle that in blue. S actually has blue eyes, and that means that would not like fishing and maybe likes another activity. And so from this, we can determine that our answer to question 39 is B. Alright, so that's question 39, and we know that question 39 is a drawing a conclusion question focusing on making conclusions. Now, a very similar question to this, to the 2021 paper, is question 8, which is also drawing a conclusion, making conclusion question, where both questions require students to work out which statement is true from a number of options using the given information. Maybe you require the use of a Venn diagram or tables to illustrate the given information to help out work out the answer. Okay, so our answer to question 39 is B. Alright, having a look at our last question for this paper, question 40. Let's begin. So question 40 says this: when the children in Freetown arrived for class yesterday, the teacher saw that 15 were wearing beanies, 8 were wearing scarves, and 12 were wearing gloves. Now, on closer inspection, he could see that all the children wearing scarves were also wearing gloves, and half of the children with a scarf also had a beanie. There were 4 children wearing a beanie who also had gloves but no scarf. There were 2 children with no beanie, no scarf, and no gloves. How many children arrived for class yesterday? Now, you can see here that is a lot of information, all just chucked into one part within. Now, that's actually quite tough when you think of it, when you see it like this. What you've got to do is you've got to break down this information little by little. And the best way to do this is by drawing a Venn diagram. So we're going to actually draw a Venn diagram. The children in Freetown arrived for class yesterday. And so if you have a look here, we've got 3 different pieces of clothing. We've got beanies, scarves, and gloves. So we're going to draw that all together because the next paragraph actually showed everything else. Okay, so we're going to do beanies here. We're going to do scarves here. And we're going to do gloves over here. So 3 different parts. Now, as you can see here, what we've been given is that 15, so I'm going to highlight this, 15 were wearing beanies. We know that 8 were wearing scarves and 12 were wearing gloves. Now, the key thing about a Venn diagram, boys and girls, is all of this equals to 15. All of this has to equal to 8, even the overlapping section, and all of this has to equal to 12. So there's actually quite a lot of information. Now, this is like the overall that you see, but on closer inspection, so this is where all the overlaps come on, he could see that all the children wearing scarves were also wearing gloves. So if you were wearing a scarf, you were also wearing a glove. Now, and that half of those children with a scarf also had a beanie. So let's just work through this first sentence, okay? So all children wearing scarves, and so we know that that was 8 children. 8 children wearing scarves were also wearing gloves, and so we know that 12 were wearing gloves, and half of the children with a scarf also had a beanie. And so half of the children wearing scarves also had a beanie. That's 4. So that means that's telling us that 4 altogether were wearing beanies and scarves and gloves, okay? And so from here, we can now fill in the other piece of information where half were wearing, he could see that all children wearing scarves were wearing gloves. So that's 4 here, wearing scarves and gloves. We are filling in this information here. So that's going to be 4 as well. And so you can see 4 plus 4 is equal to 8. So we've just finished, we've just completed this information here. Now, we know that there were 4 children wearing a beanie who also had gloves but no scarves. So wearing a beanie and gloves, so this is this section here. So that's 4 children within here. And so that's completed, and that was no scarf. So we're not going to fill out this section here. It's only this section. And then there were 2 children with no beanie, no scarves, and no gloves. So boys and girls, when you've got something where it doesn't go through anything, you've actually got to draw your rectangle and you'd write the 2 on the outside, because that means they're not wearing anything. And from here, we can slowly fill out everything else. We know that 15 were wearing beanies. So far, there's 8 here. And so that means the amount of children just wearing beanies that we can assume is 7. And the amount of children wearing gloves was 4 plus 4 plus 4, which is 12. So we don't need to fill in anything here, and either for here as well. So how many children were in class yesterday? What we would need to do is we need to add all of these up. And so when we add them all up, we would get a total of 21 children arrived for class yesterday. Now, so from seeing this question 40, we can see that this question is a finding procedures question focused on mixed number operations. Now, this question is not similar to any question in 2021. It is similar to question 19 in this paper, as it involves mixed operations. And it also incorporates elements of Venn diagrams to solve this question. And so, boys and girls, that concludes, that is our last question for our thinking skills paper. And that actually concludes today's video as well. Hopefully you had a clearer understanding of this, of the work solutions for this paper. We can definitely see areas, and hopefully you guys can, because we've identified the different categories of these kinds of questions, you'd be able to identify, oh, I might need to work a bit more on, say, working on assumptions or mixed procedures, or being able to see, compare codes and things like that. So hopefully this gave you a bit more insight, and I highly encourage you to, once you solve the paper, try solving it again and again, just so you remember how, just to check if you remember the solutions and the ways that you need to take that to solve these questions. All right, and good luck.